Howdy, everyone, and welcome everyone who's coming over from Rank's stream, by the way. Uh, welcome. I get a little pop up now when people come over from Rank's stream. Very exciting. You should all be able to hear me and all of those kinds of things. I see the little blip there, but I feel like the past two times I've started, people have then said I can't actually hear you. But I hope you're having a good Saturday. I hope you enjoyed the somewhat squished camel from the end of Rank's stream. Uh, so excellent, excellent. We just for those of you who are fans of the math channel as well, we just did some recording, sort of finishing up the last little bits of the next video is going to be going up on that. Let's see. I did want to thank everyone, especially last stream. We got a lot of new fans, windmills, and turbines, and so I wanted to specifically thank Knitting by Franco and David Ratner for being our turbines, but all of our supporters at all levels are very much appreciated. You can see Math Pesto there in the chat showing off the fancy windmill that you get if you become a supporter on YouTube, but you can also do Patreon if you prefer. And so, as usual, we start with the most requested puzzle, or the most voted on puzzle. So one of the features that you can get, or one of the benefits we can give our members, is that you get to vote on which puzzles from the bucket you would like to see me do. So the most voted on puzzle from the bucket is currently on stream. Currently on stream. Yes, there we go. Stream is the right word. It is this equal sum lines puzzle by Chili called Some Hope. So we're going to do that in a second. But so that means that this solve is dedicated to those of you who voted for it. So those would be Luda, Andrew Sarkis, Wisteria, and Dr. Proof / David Ratner. They are... So thank you to all of you for support. And hopefully you voted on a puzzle that will be nice and cool. Alrighty. So I think that is all I have for announcements. Oh, I should mention also that I recently posted the puzzle MIA up on LMD. So if you have not yet seen it, Tristan can put a link in chat to the puzzle MIA, which is one of my prouder creations as far as puzzles go. And I think the ending of it is... really something. So I really encourage you, if you've not yet done it, to go ahead and do that. So there will be a setting video for it coming out in the not too distant but not too immediate future. So you can look forward to seeing... You will see me almost cry a number of times in the process of trying to get that puzzle to work, because it was not particularly cooperative, but I did record the whole process, so we'll get a version of that out for you. Hey, Chili, welcome. And hello to everyone else, too. We've got Despicable 3, Neil, Ambrose, Tallcat, Alima, Directionary. I saw Ranks poking around, Jessica, J40, Math Pesto, SBQ. We've got a whole bunch of people here already. So I think with that, hey Alex, welcome. I think with that we can try and figure out where to start in this puzzle. So I first should explain what a region sum line is. And so the best place to start with a region sum line is, I think, with this one. So the way to think about it is every region sum line stops at each box border. I'm squinting at the screen because I saw that Jessica messaged, "Don't forget to like and subscribe," which is a fantastic message, but it hit it out of fear that it was somehow an inappropriate message, which I just can't even imagine how YouTube could think the sentence "Don't forget to like and subscribe" was notable. Anyway, oh, and then we get a super chat from David Ratner. So thank you very much. David Ratner donates $21 and says, "Have to support both today, and those of you who tragically lost the life in Texas. That was very, very unfortunate on Tuesday, and seems to only be getting worse the more comes out about it, unfortunately. But we'll try and focus on the positives and focus on region sum lines. So every region that one of these lines cuts across, what happens, hey, Naverio, changes the piece. And so you're supposed to think that you get the same sum along every piece. So in this case, the sum of all of the yellow squares is the same as the sum of all of the purple squares, which means effectively this region sum line is just an arrow. And this region sum line is just an arrow. It is saying, like, there's a circle here that's telling you the sum of those 3 digits. And that is how that works. But these are not just arrows in general, because if you took this this puzzle, for example, or this one, for example, this one actually has 2 things on this side and 4 things on this side. And so this is saying the sum of these 4 cells is equal to the sum of these 2 cells. Hey, Pause, welcome. And what ends up being really fun is we have some really, really long ones like this that ends up saying that if we sort of break this down into a whole bunch of pieces, that all of these pieces, they all have the same sum. However that ends up working out. Okay, yeah, every single one of these sections of this one has the same sum. So they're probably going to start with this line. Okay, but those are the only rules for this puzzle. So just normal Sudoku rules and this region sum line. But I am told that this puzzle is not easy. So we'll see. So Sayori is pointing out the first thing I saw, which is why I was explaining this, which is that because this is a giant region sum line, these 2 cells have to be the same because it's saying the sum of this one cell is equal to the sum of this one cell. That cell also shows up there and also shows up there. So all of those take the same value. Did I miss one? Oh, this one too. So all 5 of these cells that I have marked red, they all have the same value. And that value, I don't know what it is, but I know it has to be at least 6. So I can fill in 6, 7, 8, 9. And the reason I know it's at least 6 is because the minimum I could make these sum to is if I made them 1, 2, 3, which would already sum to 6. And so all of these things have to be at least 6. And so we can probably do some Sudoku with red. Like I know that red, and this might be almost immediately relevant, that red is going to get pushed onto this line. I don't know. That doesn't look... I don't like it. We'll look at other things. So this cell also has to be at least 6. Oops. Ooh, rainbows. And let's see, there's a few more. This also has to be at least 6, 7, 8, 9. Same reason. That reason being, again, it's summing at least 3 different digits. This one too. Did I get them all? I might have gotten them all. Row 4, column 1. Wait, what? Oh, because of the fact... Okay, sorry. So people have moved on to doing more sophisticated things. So I believe people are... Wait, what? Row 6, column 1. No, row 4, column 1. Ah, right, okay. So yeah, so people have moved on to doing more sophisticated things than the thing I was doing before. So now, in order to see that this has to be 6, 7, 8, 9, you have to ask yourself questions about this whole row. Namely, I need to look at all of these together. Yes, Tallcat is quite sophisticated, so it makes sense that he would see the sophisticated point. And so you can look at all of these 5 together, and their minimum sum will now be 15. And so the reason why that's interesting is if I look at this separately, the minimum sum of the green cells is 6, and the minimum sum of the blue cells is 3. And so you'd think, these sum to a minimum of 9. But actually, if you consider them together, you get a much better result, which is you get that their minimum sum is 15. And what that means, because this digit is equal to that sum and this digit is equal to that sum, is that the sum of these two digits has to be at least 15. And owing to that, since this digit is at most 9, in order to get to at least 15, this digit has to also be at least 6. So this is 6, 7, 8, 9 as well. And I think there was another one. Yes, same deal here with this cell, except now we're talking about this box. So within box 2, these sum to at least 15. So this digit plus this digit is at least 15. So this is from 6, 7, 8, 9 as well for the same reason. Okay, so did I miss any others? I'm not sure. Row 4, column 1, 6, 9. I'm not quite sure what people are talking about with that yet. All right. So let's have a look at this. So I was originally thinking that this was going to be a Sudoku on red sort of puzzle, but I actually don't see a lot Sudoku-wise on red. At least not that I see yet. Hey, Finnish guy, welcome. So your screen name is quite accurate if you are from Helsinki, I believe. All right. So, yeah, the red on the line in box 7, I was thinking was going to play a role in pushing up the minimum of this line. And it does push up the minimum of this line, but it pushes up the minimum of this line to 12. Because it's at least 1, 2, 3, and 6. So these two need to sum to at least 12. But don't think that's quite interesting. Let's see. The red line in box 7. Because it can't be 6. Oh, should get a bet cell. And Tristan, if you're listening, could you please put a link in the chat? All right, we'll make row 5, column 5 the bet cell. It looks like the sort of the eye of the storm, so to speak. Here. So I'm not sure what's going on with this. Tallcat is saying something about it breaking this if I make this 1, 2, 3, 6. But I don't. I guess the point is if I put 1, 2, 3, 6 on here, then I can't actually make this line sum to 6. So that's sort of suggesting that I'm supposed to actually think about these together, which is to say that these 3 cells need to sum to at least 21, because if I batch all of this together, if I batch all 6 of these cells together, all 6 of the yellow cells, they need to sum to at least 21. And so red plus these 2 needs to sum to at least 21. 21 minus 9 sounds like 12 again, though. But that doesn't quite work, but we don't quite have anything interesting yet. Which is unfortunate. I thought that was going to do it. Let's see. Welcome, Fantonia. I hope your bet of 8 goes well. Remember that red is included, though. Oh, red is okay. Okay. So this is the point. Okay, so I kind of saw the point, but then I completely missed it. So the sum of all of these is at least 21. But what I actually want to sum is the 5 of these that aren't red, because the 5 of these that aren't red sum to these two. Okay, so I'm going to color this in a ridiculous way just to sort of say this. So the yellow cells sum to at least 21. So the yellow cells that aren't red need to sum to at least 15, because there's 5 of them, which means these two digits need to sum to at least 15, which means that these digits, like the other digits that needed to sum to at least 15, come from 6, 7, 8, 9. That's the point. And so these digits are all at most 1, 2, 3, 4, 5. In fact, they are a 1, 2, 3, 4, 5 quintuple. And so this digit now sees a 1, 2, 3, 4, 5 quintuple. So this digit is also 6, 7, 8, 9. When I say this digit sees a 1, 2, 3, 4, 5 quintuple, these digits can't repeat in this cell, and these digits can't repeat in this cell. So this is at least 6, 7, 8, 9, which seems to be the point, is to say that things have to be 6, 7, 8, 9 of this puzzle so far, because we're sort of hunting 6, 7, 8, 9s. Okay, so that means, no, not necessarily. I'm going to get rid of this coloring, except for I'm going to keep the fact that red is here somehow. So this digit is down here. So it's over here. I'm trying to figure out if I can color any more of the 6, 7, 8, 9s is the thing I am most interested in doing. But I don't think I see it yet. Let's see. Okay, so Sayori is looking at row 4, column 1. That's that cell. Row 4, column 6. That's that cell. And row 4, column 9. That's that cell. And arrows in row 1, 2, and 3. So these 3 cells. Okay, that comment has been deleted, which is fantastic because I didn't want to think about it, if I'm completely honest. The fact that this saw a 1, 2, 3, 4, 5 quintuple feels super deliberate to me. Like, that's where I really sort of want to focus my attention, though. Because it feels like that's the point. Like, of the things we've done so far, the interesting thing is that fact that this digit now has to be big, I think. Because that's not at all clear until you do the logic that we've done. Hey, Eleventicles. Yeah, I am enjoying this puzzle so far. Let's see. Garion thinks I can eliminate red from being 9. Let's see. Chip wants to think about the Fistamafel ring, which seems ambitious, but possible. I mean, it's not... This should not be gray. This just is red. So... let's see. Red in box... If red is 9 in box 7, then the line needs to become 9, 1, 2, 3. Okay, so if red is 9, then the maximum sum of these two is 15. So the only way this works is if it's 9, 1, 2, 3. Okay, I agree. So in the world where red is 9, this is a 9. This is 9, 1, 2, 3 exactly. This is 7, 8 exactly. This is 6 exactly. Uh, and so then this is also 1, 2, 3. And so then you place all of 1, 2, and 3 here by none X-wings. And you can't put 3, 1, 2, 3s here. Okay, I understand that, and I will explain it just a little bit slower. So if red is 9, you have to just think about the maximum. If red is 9, then this sums to at least 15. But also if red is 9, this sums to at most 15. So it has to sum to 15 exactly, which means you pencil mark 1, 2, and 3 down here. But in this universe, this being a 9 requires this to be a 7, 8. Otherwise, this doesn't sum to 15 like it's supposed to. So this needs to be 7, 8. And so this is 6, which means that these are 1, 2, 3. But now, where do the 1, 2, 3 go in row 7? They only go in these 3 cells, except that's a problem because one of those cells is red and cannot be 1, 2, 3. Okay, so I would never in a million years have seen that, I don't think, but it is a very cool point that these digits are not 9. I mean, the punchline of, oh, you get like a double or triple X-wing that places 3 cells into 2 cells is awesome. Hey, Eric, welcome. So one of these is 9. For whatever that's worth. So okay, so here's another thing we can do is we could maximize the total sum of these 3 cells. So the maximum sum of these 3 cells is, on the one hand, it's 24 if these are 7, 8, 9. But on the other hand, it is... maybe that's not quite going to work. Because, like, this is 15, but then you got to get the red in there somewhere. And then I think it's going to get ugly. So yeah, so a consequence of this is any length 3 red line needs to have a 1, as Eric McKee points out. So this needs to have a 1 now, because the only 3 sum that you could make that doesn't have a 1 is 2, 3, 4. Should do that. Okay. This can only have a 1 on it if it also has a 5 on it, which is quite restrictive. Let's see. And this cell, I know, is not red. So this cell is down here. Okay. Maybe I should do it this way. These sum to 30. So these sum to 30 minus red. And so the other way I could calculate 30 minus red is to add the sum of all of these cells and then subtract the red. So these sum to 30 minus red if I also take out the red. So or I guess I could just say that as these sum to 30, right? Because these include all of the... Yeah, so these sum to 30. That's the really... I did this very confusingly, but these sum to 30 is the point. Let's see. Sam is looking at row 3, column 7, and saying that it cannot be 6. If it was 6... Ah, right. That's beautiful. Okay. Again, remember, and I say remember because I forgot, but then chat remembered. These sum to at least 15. So if this was 6, I could not get there anymore. So this is not 6. And that happened in one other place as well, which was over here. Now, these sum to at least 15. So this can't be 6 either. So that is interesting. row 7, column 3. Right. Again, yeah, over here, these needed to sum to at least 15, so this can't be 6. And Tallcat says 2 other places, then lists 1 other place. Let's see. Row 4, column 9 is not 6 either, says Garion, because row 3, column 8 is a minimum of 4. I don't see that. Okay. Might be worth coloring row 8, column 7, so we can chase this digit around. So this digit is not red. So, I think this is definitely worth it. So yellow is not red. So yellow in this box can only go in one of these 3 places. Oh, right, because the absolute maximum... Okay, so this is where Garion got this. The absolute maximum these can sum to is 17. So the maximum these cells can sum to is 17. Well, if you imagine pulling up your little killer cage calculator for 17 and 5, you can't do 17 and 5 without a 1, 2, and 3. Because if you try and do 1 and 2, and then you try and skip 3, then you go 1 and 2 and 4, 5, 6, and you're already at 18. Okay, so this is at least 4. So this is a 4, 5, or 6, in fact. So that means that... So, and then the whole reason why Garion was noticing that means this can't be 6. Which I agree, this cannot be 6. Hey, Nicholas! So this is an awful lot of things that can't be 6. Let's see, we know one of these is yellow, so we know yellow's up here. Okay, Alima is asking about where 9 in row 3 goes. 9 in row 3 can only go in one of these 2 cells. I agree, because 9... If 9 went on here, spoiler, it would not sum to 6, 7, or 8. And even though this one can be 9, if I put a 9 on here, it's not going to sum to 9. I mean, I did learn basically everything I know about Sudoku from watching Simon. I mean, at this point, I think it's fair to say, actually, I've learned a lot of Sudoku from all of you who contribute to the chat. But certainly I got started by watching Simon, and certainly it was all of the coloring that really made me feel like I should do it. Okay, so Garion now believes red can't be 6. Because if red is 6, it's going to force a lot of things to be 9. So let's look at those things. So if this red is 6, this has to be 9. But then there's another place. Where's the other place I'm looking? Let's see. Garion even said it. Row 4, column 1. This also has to be 9 because, again, of this row. So these two would have to be the same and both be 9 in order for that to work. Why does it not work for both of these to be 9? Or basically, why can't these two be equal is the thing I'm trying to figure out. Row 4, column 9. Would break row 4, column 9. Just these two both being 9 breaks row 4, column 9 is what you're saying? I don't think I see that. let's see. Okay, so Ambrose is saying highlight the cells in the top band that are on that are attached to these. Attached to row 4, column 1, 6, and 9. So these. And so the minimum of these is 15 plus 6 is 21 plus 3 is 24. So the minimum of these is 24 by looking at these. I've got 2 extra cells in there. Oh, no. Oh, I threw in these. Oh, no, crap. Sorry, it is those, because I'm only supposed to be looking at this cell, and this cell. And so these sum to a minimum of 21 plus these 2 is 24. So the minimum these sum to is 24, but they're also a sum of these 3 cells. And so here's the point. The minimum that those sum to is 24, but the maximum they sum to is also 24. So this is a 7, 8, 9 triple. And so red is not 6. That's the point. And that's going to do some good for the world, because it means that these cells have to be 1, 2, 3, 4, 5, 6, which is going to mean that this is a 7, 8, 9. It's going to mean these 2 are a 1, 2 as a pair. And so we get that at the very least. Okay, this can still be a 4, even if this is 1, 2. One of these things is a 6. Oh, actually, one of the things in this row is a 6. Oh, no, this could be the 6. There could be a 6 here with a 2 or a 3. That would be okay. Okay. Red in box 3 makes a virtual 7, 8, 9 triple. So your point is these are not 7, 8, 9. Okay, so neither of these are red. So red is in one of these 2 cells. So red is 7, 8, or 9. So these, someone in chat's point is, it's not 1 or 2. It could be 3, 4, 5, 6. It's not 7, 8, or 9. I'm not sure if that leads anywhere, but someone in chat explained that, and I thought it was cool, so I figured I would write it up there. This 1, 2 pair cannot include a 3. The reason is because when we minimized the total sum of these cells, we did that by saying the row cells sum to 21 at least, and these sum to 3 at least, and that got us to 24. So the only way that happened is if these were 1 and 2. Yeah, and one of these 2 is red. I don't know if that's interesting enough to mark. Probably not. Where does red go in box 2? So red in box 2 needs to go in one of these 2 places. If red goes here, red needs to be 7, this needs to be 2, and that needs to be 9. But that seems plausible to me. At least as far as I can tell, unfortunately. Oh, okay. So Tallcat has deduced that does not work through the following magic of Tallcat. If red is 7, so the only universe, let's just reiterate this, just Sudoku logically, red is ruled out of this U. So red goes in one of these two cells. So let's imagine red goes here. Then the 1 in the cage is gone. Or sorry, the 1 in the box is gone. So this would have to be a 7 and a 2 and a 9. It's not the 9 that's the problem. It's the 2, actually. Because in this universe, red is 7, and so this is 1, 2, 4. Someone earlier was asking what a Tallcatty deduction is. It's a very far look ahead like this, but that's very narrow. So noticing that every domino has immediately another domino and another domino and another domino, and spotting where that breaks. So red doesn't go here. Red goes here, is the whole upshot of Tallcat's point. So now red goes here. So now red goes, well, spoiler, red is not going here. Because if red goes here, then that's going to cause problems. Because red is at least 7, and so this would sum to at least 10. So that's not red, that's red. Which gets us our last red over here. So this cell is 7 or 8 as well. Yeah, we've had this 6, 7, 8, 9 quad. Haven't we? Oh, maybe not. No, I think you're right. I think this is new. Oops. Ah! Sorry, this is supposed to be 1, 2, 3, 4, 5. That was the whole point. Let's see. See, I know yellow is in... Well, yellow's not here. Actually, maybe yellow is there, actually. I'm not sure. Yellow's definitely in this column of this box, for whatever it's worth. Is there a different one of these I can place? I'd love to see somewhere where I can actually place 2, 7, 8, 9s, because I colored this yellow, but I don't think it's actually doing a whole lot of good for anyone to have this be colored yellow, because I don't know where it goes yet. If I knew these two cells couldn't be 7, 8, 9, that would be very helpful. Because if I knew these two cells couldn't be 7, 8, 9, I would know they went there and there. But actually, one of these two cells has to be 7, 8, 9, because otherwise they'd go there, and they would be not nearly big enough for this this mess. Row 4, column 9. In box 3. Okay, so this is not... okay, there you go. Okay, so this one... This is the correct one to look at. It's going to become yellow. Yellow can't go there. It can't repeat on its own arrow. It's not red. It's not 3, 4, 5, 6. So that is also yellow. That is very nicely spotted, Sam. So then this is the third one. And this is the third one. So these two are, say, green. So now I'm looking for cells that see red, yellow, and green, because they would be not 7, 8, 9. Let's see. The yellow is definitely down in one of these two cells. Let's see. The green down here. Don't know. box 6 line sees all the colors. Yeah, these... okay. The box 6 line sees all the colors. Okay. Every cell on this sees all of 7, 8, 9. So the point is this is at most 6. Every digit on this is at most 6. Which is not the most restrictive thing that has ever happened in humanity, but it is noteworthy. It does at least rule green off of it. Let's see. We do have all the reds placed, I think. Red equals 8 doesn't work. It makes the sum at least 15 plus 8 plus 1. Which sum is the sum? The row 8, 9 sum. This one? Is that what we're talking about? If red is 8, then this sum is at least 14. I don't know what people are talking about. I believe it's real. I just don't understand it. Where is green in box 9? It's not in column 8. Okay, so yellow is... Okay, so I like that point from SPQ. So yellow is definitely on this line. Can green also be on this line? Well, if green was also on this line, then the sum of yellow and green is a minimum of 15. It would require that this sum... But this could sum to 15. Sorry, I thought I knew where that was going, but I think I missed a key step. So I thought the point was going to be green can't go here because of the sum. Green or yellow is 9. Okay, green or yellow is 9. That's very subtle. That's super slick. So the question is, where does green go in this box? And the natural assumption is that it goes here, but it can't actually go here with yellow because of the following really complicated reason. Which is that the minimum sum of yellow and green is actually 9 plus 7, because one of yellow and 9, if you look at the triple in column 9, one of yellow and green is 9. And so that would be at least 16, whereas the maximum of this is 4, 5, 6. So green does not go here. Green goes over in one of these two cells, which means that green goes in one of these two cells. So I'm going to go ahead and pencil mark that. Oops, what did I do? I didn't mean to do it. Which means the green goes in one of those two cells. Now, does that do anything? Oh, so I think Totally Normal Cat is suggesting I look at the sum of all of these and look at what that has to be. So the sum of all of these is 30 minus red, as we've said before. So 30 minus red is the sum of all of these plus this. No, it's 30 minus 2 times red. That's what I screwed up before. Okay. I think if I would have done my math better last time, I think I would have had this way earlier. But these cells don't sum to 30 minus red. These cells sum to 30 minus 2 times red, because the sum of these is 30. So these sum to 30 minus red. That means these sum to 30 minus red. That means these sum to 30 minus 2 times red. And so if red is 8, 30 minus 2 times red is 14. I definitely can't make these sum to 14, because the ones in this row sum to 15 at least. Okay, I screwed that up infinity ago, but we're there now. And so what that means is that red can't possibly, and I think this has been true since the very beginning of the puzzle. I think I could have done this almost at the beginning. Red can't be 8. Red has to be 7, which gets us a digit dance. We get to pull in our digit dancing penguin to do the 7 dance. Hooray! 7 dance. The 7 dance is very spinny. It has been said that the 7 dance is the spinniest of all the dances. Thank you, Zach. And so, now, what is 30 minus 2 times 7? 30 minus 2 times 7 is 16. And so that's going to tell us that this digit needs to be a 1. Otherwise, I'm not going to get 16. So yeah, I feel very bad I did not get that earlier, because I had that on the tip of my tongue earlier, and I just missed that I was subtracting red twice, and then everything would have made sense. Okay, so these are not 1 or 2. So these are at least 3, 4. These aren't 1. This tall cat is responsible for keeping track of Zach's choreography. That is a very important thing of this. Okay, so this... Yeah, there's a 7 arrow somewhere, someone's telling me. I have not yet found the 7 arrow, but I believe it's there. There we go. This is 1, 2, 4. That's the point, because this sums to 7 now. So this isn't a 4. And so these are from 4, 5, 6. If you look at the... Sorry, not 4, 5, 6. These are from 3, 5, 6. These aren't 7 anymore, of course. So there's definitely a 3 over here, and this isn't 7, of course. This isn't 7 either. This isn't 7. These aren't 1. There is a 1 up here. Hey, Elosif, welcome back. Glad to catch you live again. Let's see. Okay, so these are summing to at least 13, but I guess they're summing to 14 or 15 is the question. There's definitely... Yeah, they could be 14 without a 9. Never mind. What did I do to you, Casey? I always color the 5s green for you. Okay, so this sum is now restricted. Because there's a 1 on here, the most this can sum to is 7. So this digit is actually a 6. That's the point. So the 1 that was forced up here by Sudoku is very relevant. So this is actually not, and it can't be a 7, so this actually is a 6. Which means that this is a 1, 5 pair. 2, 3, 3. This isn't a 6 either. This is a 1, 5 pair, so these aren't 5. This isn't green anymore, so this is green. So this is an 8 or a 9. So I still don't quite know where that goes, but let's see. Okay, so that's 1, 5. Let's see. Casey says this cell can't be 7. I agree with Casey. This cell is not 7. In fact, we actually know what color this cell is. This cell is yellow. That's cool. Okay, this cell has to be yellow because the none green 8, 9 is yellow. So this isn't yellow. So this is yellow. Thank you, Casey. You got us some extra coloring, which is always appreciated on this channel. So let's see. Yellow in column 2. Yellow in column 2, not on the 7 arrow. Fun fact. Not on that 7 arrow either. This is not a 7 arrow. Don't listen to me. So yellow in column 2 is in one of these two cells, is the point. So yellow in this box is in one of these two cells. Let's see. I don't think I know anything about this yet. Do I know anything about these two yet? They need to sum to 7. Oh, they can't be 1, 6 anymore, because the 1 and 6 both look at this. So these are either 2, 5 or 3, 4. I can at least say that much. This one's not 5, so this one's not 2. Also, spoiler, this one is not 3 or 4. That's the point. So this is a 5. That's a 2. So these are not 2 or 5. So that's 1, 3, 4. So that means this does sum to 15, which means that these are 6 and 9 is my only way to make 15. That's 8. So these are not 3, 4. So that's a 1, 2, 5, 8 arrow. That is a perfectly acceptable 8 arrow, so I'm happy with that. So now in this row, I still need a green. The green has to go there in order to make my life better. Wait, that can't be right. Wait, what? Oh, no, I think that's right. I think this is right. Okay, this row, let's examine closely. This row is missing 2, 3, 4, 5. No, not 5. Not 2 either. 3, 4, 6. This is not 3 or 4 though, so this is a 6. I think that is what Nicholas saw in a way that was more elegant than the way that I did, but that's okay. So these are 3 or 4. Let's see. This isn't a 6 anymore. One of these two is a 6. That is acceptable. This can't sum to 8 anymore. That's the point. So if yellow is 8, there are only 2 options here. And the 2 options, and this is gorgeous setting, by the way. If yellow is 8, the 2 options here are 1, 2, 5, can't do that. And 1, 3, 4, can't do that. That is just chef's kiss A+ setting. So yellow is 9. Green is 8. I'll get to Sayori's nice point in a second. Green is still 8. Sayori's point was my point, I believe. But very nicely spotted. I saw it as I was about to scan. So yeah, nicely spotted though. Okay, so this is a 9 arrow. Oh, sorry, this is a green. That is a good point. This is a 9 arrow that doesn't use 1, 2, or 4. So this is a 3, 6. So this isn't 3 or 6. one of these is going to get to be yellow. I don't know which is going to get to be yellow. Yeah, I haven't seen more crabs around recently, either. Okay, so this is a 7 arrow. Get an immediate response from more crabs to confirm that more crabs and Sayori are different. Okay, so this is not a 2-5. This is either a 1-6 or a 3-4. I probably know what this digit is. This is my ultimate weakness. I've actually been going through the Cracking the Cryptic Arrow app lately, and my weakness is always finishing all but one digit on an arrow and then totally not paying attention, which is exactly what's happened here. 9 needs this to be a 6, otherwise the digits don't add to 9. So this is a 3-5 pair. Let's see. Okay, what is left in this box? Let's see. We've got 1, 2, 3, 4. We need a 5. We've got a 6 and a 7. We need an 8 and a 9. Well, that one's not an 8. If this were an 8 or a 9, is that going to blow up this? I kind of suspect it's going to. If this were an 8, this would need to sum to 15, which would need to be a 9 here and a 6 here, which I could just do. If this were a 9, though, I would need these two to sum to 16. That's never going to happen. So this is not a 9. I can at least tell you that much. By the power of something, something, something. Oh, I probably should notice that there's a 9 arrow here. And the 9 arrow needs to be finishable with what I do with this. So if I make this 3-4, then I would need to make this 1-2-6. Oh, well, here's the point. These cells sum to 16. And any cells that sum to 16 in a Sudoku, if there's 5 of them, are 1, 2, 3, 4, 6. That's the only way to get to 16. And that means I know what these digits are. Namely, they are the ones that aren't those. So they are a 5 and a something else. A 5 and a 9 is what is holding out over here. And so that 5, 9 is going to break us into all of this, because it's going to tell us that's a 3 and a 5. That 3 is going to bounce down here and tell us this isn't a 3. Maybe I was overly optimistic to think that this would help. The 1, 4 down here, I still need a 1 and a 4 and a 2 in this column. Yep, that's all I need in this column. Let's see. Okay, these two need to sum to 7. I just need to actually look at all the region sum lines and figure out where I get one that's restricted. Okay, these two sum to 9 without involving a 7 or an 8. So they're either 3, 6 or 4, 5. Which, if I fill in this cell, will get me a 1, 2, 3, 4, 5, 6 sextuple in the row, but I don't think that's going to be super useful. Let's see. Oh, Fantonia believes the bet cell is 8. Oh, well, 8 is definitely not on that line. 8 is not up here. 8 is not over there. So one of these two is definitely the 8 in this box. Oh, wait, no. How do I know 8's not there? Oh, because 8 is one of these two cells. I should corner mark the 8s. So 8 is looking down. I think that's called pointing 8s or something. So 8 is actually going to get plonked into the bet cell because I can't put 8 on a 7 region sum line. So this cell is green. And so if you bet that the bet cell would be colored green, you bet correctly. So I really should have people bet colors for the bet cell. Oops. Ah! Sometimes I hit that button and I don't know what happens. Oh, yes, please. If you are in chat and you have not yet liked the stream, it would be an excellent time to like the stream. Okay. Do I have a sextuple here? No. But I do, because this is also 1, 2. Okay, so here is my favorite thing in all of Sudoku. This is a sextuple in column 5. So 1, 2, 3, 4, 5, and 6 are gone. So therefore, this is a 9, not a 6. And so it's yellow. And that's a 6, which doesn't get a color in this puzzle. So this isn't 6, so that's not 3. I mean, really, the Betzel, I guess, was lucky to get a color in this puzzle, because this puzzle has not involved a lot of colors. Let's see. These need to add to 7. Is there a combination here that does not work? If these are 3, 6, then this can be 2, 5. No, I don't think there is. Let's see. Six in box 1. Probably in one of these couple. Actually, this 3-6 pair. So the 6 in box 1 is part of this gang. Is Tallcat's point, not the 2. The 2 was just added at random. So enjoy painting the town, David. I hope to see you around again soon. Have a great time. So one of these is a 6. So this isn't a 6. Now, that tells me, and this is gorgeous, just amazing, this can't be 5, because if it was 5, I would need 2 6s here, and I can't do that. So that is an 8, and is green, which means that this is a 6 and a 9. Now, the 9 I already knew was in one of these two places, so the 9 is not here. The 9 is here, and this is yellow, and this is a 6. So there's no 6 involved in my 9 sum, nor any 5, so this must be 2, 3, 4 in order to add to 9, which means that there's no 3, 4 over here. This is 1, 6. This is a 1, and a 4, and a 3. So this is probably figurable outable. 1, 2, 3, 4, 5, 6, 7. This is an 8. Spoiler, this isn't an 8 anymore for various reasons. This is 1, 2, or 4, but it's not a 2. So these are 1, 2, 4, except those aren't 2. These are a 1, 4 pair, so that's the 2. The 4 looks up and resolves. That's a 1 and that's a 4. That 4 bounces over here and gives me a 5, which bounces back here and gives me a 9, which gives me a 5 up there. The 9 is yellow. Oh, and there's an 8 in there. That 8 tried to sneak by. The 8 is green. Oh, welcome back, Franco. All right, this is not a 5. This is a 3, 4 pair to finish off this box. That gives me a 3, 4 pair in the column, which means these aren't 3 or 4. So these sum to 11. They're not 5 or 6. This isn't a 1 either. So these sum to at least 13. These sum to at most 13. So therefore, this is a 4. This is a 2. In order to maths that right. That 2 looks down, gives me a... Let's try again. The 2 looks down, gives me a 5 and a 2. Let's see. These cells are a 1. We've got a 2. We need a 3 and a 4. We've got a 5, 6, 7, 8, 9. So these are 1, 3, 4. That one's the 3. Let's try again. That one's the 3. Who knows what these are? It is a mystery to all of us. Let's see. This is unwinding in a very cool way. The 5 here looks down to a 1 and a 5. The The 5 here looks up and says that's not a 5, and that's not a 5. So that's not a 2. It's also not a 1. Let's see. Oh, I need a 9 in this row. That's a good point. I need a 9 in this row. Where is it going to go? Well, it's not going to go in any of these spots I have pencil marked that can't be 9s. And it's not going to go here where there is a 9. So the only place for the 9 in the row is here. So this really is yellow. This is really not yellow. So this is a 9 and a 5. And so I probably can then figure out where the 9 is going to go in this box, which is to say it's going to go yellow. So I think that's all my yellows. So I think I might have all my yellows, greens, and reds done. If I have carefully done this. Okay, this 2 looks over here and says that's not a 2. Let's try that again. This 2 looks over here and says that's not a 2. So this 3 looks over and says that's not a 3. The 5 does work. That 5 looks over and gives me a 6 and a 5. The 6 looks back and gives me a 1 and a 6. Let's see. The 5 here. Growing ever closer. Okay. There's too many pencil marks here. This is either 3 and 6. Or, okay, so this can't be 4 anymore. That's the point. This is only 3 or 5. This can't be 5, so this can't be 2. Let's see. Am I missing other... There must be pencil marks that I'm screwing up here. So this can't be 6, because that can't be 1. So this is 1, 3, 4... Box 4 or row 4 already has a 6. Oh, okay. Elosif has the much easier way to do this than I'm trying to make this into some weird quadruple. But this 6 here puts a 4 here, which I bet is going to do a lot of damage because these two need to add to 9. So that's going to be a 5. That's going to be a 3. Now I'm not allowed to use a 4 down here. So I'm not allowed to use a 3 either, so I have to use 1 and 6. So that gives me a 3 and a 6. That gives me a 2 and a 4 and a 1. This is now a 2. This is now a 3. This is now a 4. Let's see. The 1 here goes over 4 and 1. The 4 looks back over here. Says this is not a 4. Oh, there's a 3. It's not a 3 either. Spoiler, 2, 4. That's right. It's ELOSF is the preferred pronunciation. Thank you for reminding me, Tristan. That is a 3. And that is a 2. There we go. Nice puzzle. I enjoyed that one a lot. There was the break-in here, sort of very carefully studying this was very interesting. Lots of this, and I mean, it's sort of clear what you're supposed to look at, but I think the magical looking at exactly this set of digits was quite interesting, and I was not expecting it at all. Yeah, region sum line puzzles are almost always fun. They often have some tough break-ins, and this break-in was pretty tough, but nothing totally untoward, but it was definitely tough. But then it wrapped up pretty nicely. Like, once you sufficiently understood the break-in, it was sort of like levels of enlightenment kind of thing. Yeah, I mean, it was not like it was a mystery what to look at in the grid in order to figure out how to make it work. So yeah, I agree with Naverio. It was well telegraphed. Panthera is asking about my favorite colors, which is a somewhat complicated question. In board games, I'm always black, but I would say black isn't super a color. I mean, it's not as bad as 5, but you know. So probably purple is my favorite colory color. Uh, Neil asks if you could do a chaos construction puzzle with solely region sum line clues, and I believe Woofers and Jacob did that in a puzzle called The River. Uh, there have been a number of chaos constructions that have region sum lines plus a few things. Now, I guess you could argue The River had given digits, and so you could say The River doesn't count because there's given digits. But if you wanted to do no given digits, and no other types of clues, I think you could do it, but I think it would be unpleasant. Uh, but it would be very interesting. All right. I'm going to take a very quick break, and then we'll be back with more puzzles. So be right back. Welcome back, everyone. We have 2 new patrons / members in the time, so thank you to ELOSF and GeoJesser for supporting the stream. Much appreciated. Yes, we're going to now do this puzzle again. Let's see. No, I wanted to switch and do... I wanted to switch to Penpa mode and do... this Jesper Japanese sum Fillomino, which I'm slightly terrified about, but also am interested by. So I want to read the rules carefully and then do the puzzle. So, I mean, wanting the emotes in the green name, that's a perfectly fine reason to support the to support things. And to get to see the dancing T-Rex, who's actually friends with Zach behind the scenes, so don't worry, there's no jealousy there. They have their clear roles in the organization, and they very carefully work together. Okay, so this is a Jesper puzzle, and so Jesper tends to have. If you've not seen Jesper's puzzles, first of all, Jesper's puzzles are all amazingly rated on Logic Masters Germany. Like, basically all of them are 99% or 100%. They tend to be difficult, but they all tend to involve really heavy geometry. So we've got this. Technically, Casey, you can support us through both Patreon and YouTube members if if you feel the compulsion. Let's see. So let's read this carefully. So we need to shade some cells, and so this is an example we're looking at now. This is Jesper's Japanese sums Fillomino. So we need to shade some squares. And then divide the rest of the grid into regions. And so this is the Fillomino part. So if you've seen Fillomino before, you make polyominoes, which all contain the digit, which is their size. By the way, maybe this is a good point to mention. Fillomino is not a form of Sudoku. So you'll notice the repeated use of the 3 and also the use of the 10s are somewhat hints at this. So there are a few hints, but this is nothing Sudoku like at all. So normal Sudoku rules do not apply. So that's the Fillomino part. There's one more part to Fillomino, and that's that if two regions have the same size, they cannot share an edge. So if I have my 5-omino, it can't touch another 5-omino. Set a Kropke Fillomino, Sam. That is my suggestion. A negative constraint Kropke Fillomino. That is my suggestion. If I set a Fillomino, it will probably be that. Although I will confess I have an idea for like a crazy pack of Fillomino puzzles that I might work on at some point. Okay, I'm going to slide myself half off screen while we look at this. Actually, I guess you don't need to see the unfinished example. You just need to see the finished example. So I'm going to put myself over here for a second. I mean, in a way, MIA, which is my latest puzzle, is sort of a Fillomino puzzle. And I kind of want to expand on that and maybe get rid of the Sudoku part. So I have some ideas I've been kicking around that I might make into something. Oh yeah, I definitely, when I said Fillomino, I was definitely going to make it a negative constraint. I think the negative constraint is important. Okay. So that's the Fillomino part. And then we have the additional part, which is the Japanese sums part. So clues outside the grid indicate the sum of groups of adjacent numbers in their respective row or column separated by at least one shaded square. So for example, this 7 here is giving us the sum of 1, 3, and 3. 1, 3, and 3 is 7. This 3 is giving us the sum of 3. Okay. And note these sums are separated by my black bands. And always clues, and this is traditional in Japanese sums. Once you get a clue, you get all of them. So this is really telling you, when you see this, there's 1, 3, and 1, 7, and nothing else. There are no sort of missing chunks. And then there are some clues where we don't get the real clue. We just get a number of dots that tells us effectively the number of digits in the clue. So this double dot is in this instance standing for 10, because the sum of 10 is 10, a sentence I did not think I would be saying today, but that here we are. And so you'll see in this row, in row 2 here, we have a sum of 7, which is represented by 1 dot, and then a sum of 14, which is represented by 2 dots. And it does specifically say there are no lying dots, so there's no like dots standing for 0 as the first digit or any such nonsense. Okay, so I believe that is everything. So let's open this in Penpa, and then let's... Okay, so this is not the right size. We need to zoom out somewhat. Oh, I think I'm supposed to use the resize button somehow. Display size. Okay, let's change the display size down to 34. And then I need to move the zeta out of the way. So we're going to move the zeta over to here to slightly stand in front of the rules. Okay, I guess if I'm going to stand in front of the rules anyway, I might as well cover all the rules, because I don't think covering a tiny bit of the rules is really going to do anyone any good. So there is me. Here is the grid. I think you can see everything. My first instinct looking at this is to say, oh, I should be able to make the grid way bigger, but I don't think I can, because I think actually everything you can see you need to see. Yes, you get bonus big zeta for this puzzle, because otherwise I'm just not using the screen for anything. I could overlay the rules on top of my face. They could just scroll over my face. That might be helpful for some viewers. But anyway, this is one of those puzzles where if you need the rules, I think you just need to click the link if you need to look at them. We may need to flip back to them. I did deliberately leave it so that we can do that. By the way, this is a pro tip for Logic Masters Germany. If you're ever doing a puzzle on Logic Masters Germany, don't click the link, right-click, and say open a new tab, because otherwise it will disappear, and I do not like that. All right, so I think you linked. Alrighty, so here's our grid, and so we're going to have to figure out how on earth to do anything with the information that we have been provided. So admittedly, this is fairly terrifying. So a standard trick in like Panthera's Japanese sum Sudoku puzzles is to look at rows or columns where you sort of know you have all the clues because of the number of them. But here, I'm not sure we can do that in any of these places. Because, like, for example, in this row, I mean, I could just write a 10 into a cell. Well, I wasn't claiming all of your puzzles work that way. I was just saying that's where I... that's where I start in anything Japanese sumsy. That's sort of my inclination. But here 4 is the most, and this is a 10 by 10 grid. 3, 4, 5, 6, 7, 8, 9, 10. Yes, it's a 10 by 10 grid. So in order to know exactly what... Actually, there's no combination of clues that would tell me exactly what was happening, I don't think. So I guess I could say things like, I know the first clue in this column is a 2, because 2 could never be a sum of 1 plus 1, because that would be a 1 next to a 1. So somewhere in this column, the first clue is a 2. Now, is there any way that I can get anything useful out of the fact that I know that the first clue is a 2? Yeah, this is a 20-something, but keep in mind, I could literally write 21 into a cell. Although, I can't actually, in this instance. Well, I could... write 21 into a cell, but I would have to somehow not enter this row, because actually whatever cells are up here, they have to either finish in this row, which I could not finish something more than 10 in this row, or they have to break into this row. And so the breaking into this row part is interesting, because when you break into this row, you know the sum is at most 10. Okay, and so I think this row must be telling me something about this 20-something that's very interesting. Let's see. So Garion points out this 2 I should also look at. I was scanning for another 2 and I didn't see it, but there's a 2 here and there's a 2 here. So there's a 2 up there. That's the first clue in this column, is a 2. And there is a 2 here. Yeah, I explained why this can't actually be a 20-something. It's in fact at most a 10-something because of row 2. You have to look at row 2 specifically to get there. So I actually was thinking this was going to have to be the 2. So what if this is black? If this is black, then I need to get my 20-something either entirely before this, or I need to get to 20-something after it, using at most 10. And I always need a black between any grouping. So in order to get to 20-something, I need at least 3 cells. And so if I didn't put my 20-something here, then I would need to start my 20-something here. It would take at least 3 cells. Then I would need a black afterwards, and then I would need a single digit, and that's never going to work. So if this is black, this is the 20-something. And then there's a 1-digit thing. It could be that. And then there's a 2-digit thing. It could be over here and it could easily fit. That is all very unfortunate. Okay, let's see. Garion says if row 1, column 4 was a 2. So Garion is imagining this universe. Then row 1, column 5 would be the 2 next to it. Right. It can't go here, at least. Why can't it go? Oh, can't go here. So yeah, so the 2 here is immediately followed. So I think this is useful to do just to get our brains around this. So Garion is saying if this is a 2, something is going to go wrong. So this can't be a 2 because then this clue wouldn't be a 2. It would be a 4 or more. This can't be. So one of these 2 is a 2 in this universe. Although I'm not now sure exactly how I would decide which of these would be the 2. Let's see. Yeah, I think the 20-something is likely to be, as Judith says, maybe like a 3-cell 9 region or something like that. But yeah, I don't quite see how I know which direction the 2 goes, because I can sort of batch these things together, which is the sort of the really annoying part of this, is that I can sort of like, this 20 clue could involve a 2, for example, and that would be fine. But I think it's good to think about. like I feel like the twos have to be part of the break-in. Uh, if this is not shaded, so again, if this is not shaded, these three all have to be part of the 20 something, and they have to be at least 7. Uh, and so then this would break down, and then this would end up triggering the 9, however. That would be fine. Let's see. No, Panthera. It's fine. It could do 9999 would be fine, for example. And then this could be the first 9 of the row, and then have a black on either side. I don't think there's anything wrong with that, Panthera. It's really annoying that there's 3 cells here. I wish there were 2 cells here. Then I could know for sure that this couldn't happen. You agree, right, Panthera? Just with what I showed you? It's very possible I'm misinterpreting the rules. Yeah, it can add to 20. And so it's probably a bunch times a bunch or something like that. Now, somewhere in this row, there's a 2 with a black on either side, which is interesting. Let's see, are there any other dots that are interesting? There's just not quite enough congestion here, it feels like to me. Let's see, there's in column 1, there's a 13 and then some black and then a 2 dot area. I do need 3 different dots in this row, but that still leaves me lots of room. This row I just know absolutely nothing about. There's not even a clue in it. Okay, that's interesting. Okay, so that's okay. I think Acid Helm has a good thing to look at, which is this 13 clue. Okay. So a 13 clue can't be made up of 13s because of row 2. So the 13 clue has to be made up of things, and it has to be made up of 2 different things because 13 is not a multiple of anything other than 1 in 13. I guess, sorry. It could be an actual honest 13 clue if it started low enough. But if it wanted to start quote unquote low enough, it would need to still start below here, because this column starts with that. Yeah, I should be very careful, but the 13 is almost certainly not a 13. It's almost certainly something like a 6 and a 7 or a 5 and an 8, and that creates some interesting stuff. Okay, and this... Yeah, so if I imagine that there actually is a number here, it does create a very strange universe that's very specific. But I'm having a hard time figuring out, exactly what goes wrong. So So if, let's just imagine, this is part of some region, if it goes down, well, if it doesn't go down, then we're already, well, this is hard to talk about. I don't have words for the kinds of logic that are happening in this puzzle. Yeah, the 13 here is a very good thing to notice, and it was wise of Acid Helm to notice the 13 that I had been heretofore ignoring. Should I be asking about this 5? There aren't that many things a 5 can be, actually. It could be a single 5, or it could be like a 2 and a 3, or a 1 and a 4, and that's about it. A 1, a 3, and a 1, I guess, unfortunately, is possible. Which of these am I supposed to be looking at? There's got to be a 7 here, which is interesting. 5 could be 1, 2, 2. That is another way of making 5. Unfortunately, I agree, Jay. Yeah. I feel like it would be really natural for this to be the 2. Okay. Can this be the same 2? It can't be the same 2. Okay. Beautiful point, Judith. So, so I've been thinking this whole time that the very natural thing to do was to put a 2 here and be done with it. But that doesn't actually work, because the 2 needs to be accompanied with another 2. And if that 2 goes vertically, it breaks this 2, because now the sum is 4. If that 2 goes horizontally, that breaks this 2, and the sum is now 4. So actually, this 2 and this 2 are different dominoes. So that's actually very interesting. So them being unable to be the same domino means this is not a 2. Oh, okay. So what are the possibilities? So if this cell can't be a 2, then it can't be anything else either. So we're going to have to double check this. But if this cell was a digit other than 2 that wasn't black, then the puzzle immediately breaks, because you could never make this 2 work. So, like, if this is a 5, well, now this 2 is never going to work, because I either have to put a 2 up here, in which case I'm getting to 7, or I make this black, in which case I'm not getting to 2. If this cell is a 2, well, then I have to blacken this and this. But now somehow this 2 is not part of that 2. So this 2 has to be part of the 9, I guess, which is unfortunately annoyingly plausible. Like, I don't immediately see why I can't just make that 2 part of the 9. Okay. So, yes. Okay, so now, this 2 has to be part of the 9. And now we go back to the fact that we know all of these now are forming a 20-something region, because we already proved if you just make all of these black, you can't fit the rest of the row. Okay, so good point, Panthera. So these are all forming something. These are at least 7 in order to get to 20-something. Could be part of the 5. So now this thing that's at least 7, it's got to come down. And so it's also going to be part of the 9. It's going to have to come down like this. In order to make it a 9, it would have to be exactly 7. And so it would have to keep going down like that. And that doesn't work because of this double dot. That double dot is important. Okay. I think I can disprove this. I have no earthly idea if this is what Jesper intended or not. But this could be 20. And in fact, so let's imagine the world where this digit is a 2. And so in the world where this digit is a 2, we're forced to... Oh, this is broken way easier than I'm making it. Yes, this is... So, sorry, this is way easier. Okay, so the thing I forgot was the 2 needs another 2. Either there or there. But purple is at least 7. Because if purple's not at least 7, I can't fulfill this 20-something clue. And so now this sums to at least 11, which is more than 9. So that does not work. Okay. And so what that tells me is this cell is not a digit. So we have a pencil mark. This cell, or we have a thing filled in. This cell is nothing. I believe we have proven that. Feel free in chat to tell me if you disagree, but I think we've now proven this can't be a 2. It can't be any number that's not a 2. And so we can fill in nothing. Yes, and so we should have a void dance. The void dance, the zero dance, from Zach, the sort of like the zero gravity dance, we'll say, for proving the absence of a digit, as Zach slowly floats through the space of the studio. Thank you very much, Zach. Much appreciated. I don't think you've gotten to do a void dance before, so that was new. Okay. So now the question is, if I don't fit the 9 in before this, am I just dead? Because if I make all of these black, then now I have to fit clue black, clue black, clue black, and I don't have enough space because I only have here 1, 2, 3, 4, 5, 6. I don't have enough for clues. So there has to be something over here. So the 9 is fulfilled over here in some fashion. There are multiple ways in which the 9 might be fulfilled over here, but the 9 needs to be filled over here. And it's maybe technically possible. No, it's not possible that I do both the 9 and the 5. So there's got to be a 5 and then a 2 over here somewhere, and then a 10 somehow. Okay. So it's a little bit of progress. A little itty-bitty bit of progress. So next, I think I want to go back to, can this really be black? So this black cell is actually black. This cell I'm going to make gray because I'm speculating about what happens if it's black. And so what happens if this is black is I'm forced to fill the 20-something over here, and that's going to look like that. This digit is at most 9. And so now this is a double-digit number, so that's forced to be filled in order for this to work. That's the thing that I noticed that I had not previously noticed. Well, whatever makes 20 definitely has to go down. There's no way the thing that makes 20 doesn't go down. Oh, and this is also double digit, so that also does that. In this instance, Panthera, it has to go down, because if it makes something that's at least 20, if it's like a 10, you can have 10 in a single digit, but you can only put 10 in a cell if it's part of a region of size 10. And a region of size 10 definitely has to enter row 2. Yes, right. It'd have to be a 10 size region full of 10s, and that's not going to make it through row 2. Because row 2 has all of these little itty bitty numbers. Oh, and the 13 too. The 13 also would need to have something like that. So if this cell, well, I guess, sorry, my purple here doesn't actually mean it's all part of the same region. My purple here just means it's all part of some region, as of yet unspecified. But this is not leading me to feel like I'm going down the right path by asking this question. I feel like I've asked the wrong question. So am I possibly supposed to be asking the question, can this be a 2 instead? If this is a 2, what does that do? I mean, among other things, it forces the 2 to be part of the 20-something. Well, the 20-something can't escape to the right. I mean, part of it can, but remember that whatever the digit is, that can't go through the 2. That's going to have to go down and push through here. Where it's going to have to involve a digit that is at most 9. Yeah, I don't see what I'm doing with this 2 as of yet. Could be wrong, but I do not see it. I do know the 9 has to be made over here, so that I did prove. I have to get to 9, and there's not that many ways to get to 9, I suppose. So I could get to 9 as a single 9. This is confusing. Like, all I feel like I know is I think I know this cell is black, and I think I know there's at least one digit in one of these 3 cells. And I don't really feel like I know a whole lot other than that. I might be able to convince myself that, like, something like this cell has to be a digit by doing more traditional non-gram stuff. Good night, Jay. Maybe when you wake up, we'll still be doing this puzzle. We'll see. So what if this isn't a digit? Maybe that's the question I'm supposed to ask. If this isn't a digit, then because I can't get to 20-something in these 2 cells, these are automatically not digits. Now I have to get to 20-something, which is going to require at least 3 cells. Which is going to cause all kinds of problems. And then I have to have space. And then I have to have a 1-digit thing. And then I have to get to a double-digit total. And this just works. Because this could be a 10. It's so close to failing, but this could be no, it doesn't work. It doesn't work. Because even though this could be a 10 and that 10 would be okay, this 16 is broken. Okay. I have something. It's a very little thing, but we don't have enough room to make this not part of a region. So this is definitely part of something. This is part of a sum. Provided that I counted that right. Alex may be telling me I didn't count it right. Okay. Yes, you were noting the thing that I was about to notice at the very last second, or that I was petrified about. But yes, it does break the 16 clue. Okay, so I don't know how many minutes are into we are into the puzzle because I don't see a timer, which is probably good. But we have learned a cell that is part of a region and a cell that is not part of a region. We are doing great. Okay. So Garion says, I think if row 1, column 4 is not part of the 20-something clue, then the 20 plus Fillominos extend down enough to break the totals for the 9 clue. So you're saying now you think this can't be black? Okay, yeah, there's... Okay, so let's try and imagine now that this is black. And so let's really try and think about what happens to this. So all of these are green automatically. The size of all of these is at most 9. So these things are at most 9. But they therefore have to be at least 7. Because if they're not at least 7, I'm not getting to 20-something. But the 13 clue is broken. In this instance. So these all, in this instance, these all become part of an omino that's at least 7. But now either that omino continues down here, in which case the 13 clue breaks, or it doesn't, in which case the 13 clue breaks. Right? Or could I do something like, this is a 7. Oh, no. I could do something way more heinous than that, unfortunately, I think. I think I could do this. This is the thing I'm worried about. I could make this 8, 8, 8, 8, 1. And then make that black and have the 8 continue down. And I think then it all works fine. And then make this, say, a 4 in order to make the 13 work out. Well, that doesn't quite work. Oh, column 3 is broken. Okay. So I need to also think about column 3. By the way, Nicholas, very reasonable question. Couldn't this be 6, 7, 8? The problem with this being 6, 7, 8 is then I need to fit a 6 omino, a 7 omino, and an 8 omino in here. All of those, by my usual logic, are going to have to continue down. So I'm going to have to do that, and that. And now my total here for this row is now approximately infinity. This 9 now has a 6, 7, and an 8 in it, for example. So I really can't fit. I can't put more than one type of omino up here unless I do it in a very, very specific way. But the two things I put up here, definitely, if I do put two different things, they both need to show up in the 9 sum. Okay, so oops. Okay, so the 13 okay, so yeah, I think I'm inclined to believe, Garion, that this is going to break because of the confluence of this 13 clue and this double-digit clue. And that double-digit clue. But... Yeah, okay. So I think here's what I think I can make sense of. So in the universe where this is darkened, all of these have to be part of a region. And green here doesn't mean they're part of the same region, they're just part of a region. But all of these numbers need to be single-digit numbers, because otherwise I'm breaking this 9. Well, that means this, and this all need to be part of a region too. Because of that double dot, and that 13. So one of these, at least, is at least a 7. Oh, no. Okay, so one of these is at least a 7. So the only way this works is if this is exactly this, I think. So I think the only universe where this could possibly work looks like that. Unfortunately, this still looks plausible. Like, this still does not... I don't think we've broken any clues yet, have we? It would have to be exactly 3 7s, a 7, and 2 1s. But I don't think that breaks this 9. Oh, yeah, the 7 would have to continue to row 3. I agree. But, I mean, the 7 could then go over here, or it could continue down. Yeah, Garion, I agree. That is actually exactly the kind of configuration where it makes me think that's going to be the arrangement, not that it's not going to be the arrangement. Yeah, column 1 has to continue down, but I mean, I can put something else there. I feel it's very unlikely that I'm supposed to continue further down from putting that many digits in here. So I wonder if it breaks if I put a 2 here in a more simple way. So if I put a 2 here, I mean... Okay, so there does have to be a domino of 2s. Sorry, no, there has to be a vertical 2 somewhere. The vertical 2... I mean, I feel like it could be there, is the problem. Like, I don't see why it can't be there. Okay. Maybe the clue is this 14. I think the clue might be this 14. Because look at the bottom of this column. If the 14 is actually... So the 14 could involve at most single-digit numbers, so it would have to involve at least 2 cells. in order for this to work. And then we could have 2 cells and a blank, and then a cell and a blank, and a cell and a blank, and a cell. And then we still got 2 left. Okay, that was terrible. Very regrettable all around. There's pressure there, but it's not nearly enough pressure is the problem. Okay, so this 20 is min 3. Okay, so this is min 3, plus a border is 4. Min 1 is 5, plus a border is 6. And then is this min 2? Okay, so 3. I'm trying to minimize this and see if this is actually the thing I tried to make it at the very beginning. I'm going back to not thinking about the 2. Oops. Though I might think about it in concert with the 2, we'll see. Okay, but the 20 needs to be at least 3 cells. Then we need a blank. Then we need at least 1 cell, and then we need a blank. And then we need at least 2 cells, I think, for the 10, but that's not even great. Or for this double-digit number. But that still leaves 2 cells of flexibility. Maybe that's where the 2 comes in. So what if this is a 2? Now I have a 4 in this row as part of the 20-something clue. But what's the minimum number of cells the 20-something clue is now? Isn't it now minimum 5 cells? Because 4, okay, so 17. Why not 8, 8, 2, 2? 8, 8, 2, 2. Okay, so it's only minimum 4 cells. If it's 8, 8. And 8, 8 seems maybe possible. Hey, Ranks, how are you? Yeah, I think you're right. I think 8822 seems plausible. And couldn't this 9 clue get an 8 and a 1? No, because of the fact that that all of these need a cell. So I guess the thing I'm really trying to rule out is the fact that this is where the 22 ends. Or sorry, where the 20-something ends. And I think we can rule that out because if this is my 20-something and it ends here, then all of these are full, and one of them contains an 8, and that's broken. So in fact, this would also have to be some part of the 20-something. So in the universe where this is a 2, actually, all of these have to be part of the 20-something now, owing to that fact that 8 plus 1 plus 1 is more than 9. So all of this is part of the 20-something. And so now I could put a gap here, and then I'd have to put a cell, and then I could put a gap here. But then it still looks like I have freaking room to put the double-digit thing here. I'm really enjoying this one, even though it is absolutely destroying my brain, and I feel like we've made basically no progress. But I am really enjoying it for what it's worth. There's not some magical rule about shaded cells that I'm missing or something, is there? It just says shade some cells. I think there's no further rule about shading. But this just works. Why am I wearing earbuds? No good reason whatsoever. But because my producer didn't tell me not to until just now, is why I'm wearing earbuds. So yeah, I would love for someone to shout out the reason why this is obviously broken. So sad. Yes, the you can tell from how well this is going that I'm getting hints in my ear. Yes, that breaks because row 2, column 5. 2, column 5. This cell would have to be a 2? Oh, because of this row's 2. Right, we have not yet taken care of this row's 2. So... But... why would this have to be the 2? Yes, I understand regions of the same size can't touch, but why can't I just blacken this out? And then put my 2 going down here. Yeah, this would be black in this continued universe, which now makes this a 1 or a 2. Oh, no. Okay, I cannot imagine. There's basically a 0.0% chance that this is the intended path, but this is now broken because of the 9 of all things. Okay, so let me explain Andrew's point just because there's some small chance that you might be confused by something that's happening. Because I now, after I get the 9, I have to get this 2. And I don't think it's possible that I've gotten both the 9 and the 2 before this point. That's right. I can't have gotten both the 9 and the 2 because all of these need to be shaded. So now this cell can't be a 2 because it would inevitably touch this 2. Unless this is a 1, and this is a 2, and that's a 2. But then that probably means this isn't getting big enough, right? Because 2s can't touch. So let's just try it. So if this was a 2, it could not touch this 2. So this would have to be a 1, and that would have to be a 2. And now this would need to be a 2, and these would need to sum to at least something teen. Lord. Seems impossible. So they would have to be at least both 8s, right? And then that breaks because you can't put an 8 in here because all 3 of these need to be shaded. Okay, so this is certainly not the intended observation, but I believe it is sufficient to disprove this being a 2. And so if this cell isn't a 2, it's black, and I think we get to actually put in a bajillion things. So now all of this is green. All of this is green. And I think we decided the only way this works is as 7, 7, 7, 7, 1, 1, 7. This can be green. I'm going to start putting in edges. I can't imagine, having done the number of Jesper puzzles that I have, that's intended unless it is part of a well-known solving technique that I do not know about. Okay, now this at least has to be green because I'm not to 13 yet. This has to be green because I'm not to a double-digit number yet. This column I can end any time, though I don't, strictly speaking, have to. It is true that I could have done the practice puzzle. That would probably have been the smarter thing to do. I'll be honest, I intended to do it and then I just forgot. It was not a deliberate effort to be super cocky. Although, boy, if I was trying to look cocky doing this puzzle, it's not going well. 7 can't go left in row 2. Right, the 7 can't go left because that would be too many. I agree. Yeah, after this, we'll do the practice puzzle. And this one, hey, Jovi, welcome. This is part of the same Fillomino as this. I can actually draw that in because this is touching a 1. So even if these were double 3, that already overflows us. So this is double 2. Okay, so I think we're getting somewhere. So this is a 2 and a 2, and now we're still not at 13, right? So we need a 1 here. And that's green. We just broke into this puzzle in the least humane way possible. I know this is green. So now we've got all of these digits, provided that we believe that we have not yet made a mistake, which is, I don't know, I'm like 60% confident in what we've done so far. Okay, and then there needs to be... we got a void dance from Zach. Zach danced for our first black square. The rare lack of digit dance. Okay, so now... Okay, so now Judith says row 4, column 2 must be black or the row is too cramped. Okay, yeah, if this is green, I now have to fit a black cell and then a clue and then a black cell and then a clue and then a black cell, and I still need another clue. Yep, okay, I agree. And for whatever reason... I fear I know the reason. The statement "something is black" is not acceptable to YouTube, so thank you, mods, for approving people talking about black cells. So now the 7 has to come here. And now the 7 absolutely cannot touch this cell because this cell column still needs a 2. So the 7 finishes here. So surface, green, edge, edge, edge. Doop, 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 doop. Okay. Now, this cell has to be green because of the single cell clue. No, sorry, because of this double dotted clue, which now means this has to be my 2. Because if this was the 2, I'd have screwed up. So, in fact, this is black, this is a 2, and this is a 2. And therefore it looks like this. So we get all of that. Yes, as Judith says, the 2 has to be horizontal. Hello, Ken. How are you? We're having... Well, I'm having a lot of fun with this this Jesper Japanese sums Fillomino that may or may not have destroyed my brain. But hopefully you are having a good day as well. What kind of thing do you sell, Jovi? That probably depends what kind of thing you sell, but that sounds unfortunate. Okay. So now... Black clue, black clue. Okay, we're not quite at the point where we need... I don't think we're quite at the point where column 2 is forced, but we're close. column 2. Yeah, column 2 I think is one cell over minimum. The 7 here is very interesting. Okay, the start of this column is a 9. Is there a universe where this is not part of the 9? Can I shade the rest of row 4? Well, I don't think row 4 is over yet, right? I could put more stuff here, but once row 4 actually gets a black cell, all of the rest of it is black. But I don't think, let's see, row 5, column 3 has to be green, says Garion, because otherwise this would have to be at least a 9. And this is a single cell. This is a single digit sum. And so if this was at least a 9, right, so if this is black, so this is the universe that we're explaining why it doesn't happen. If this is black, this cell, which is a single digit, has to be a 9, but then there's another 9 below it, and it's not a single digit. So that's not black, it's green. I apologize to everyone who is bothered by the fact that the black outline and the black squares don't play very nicely together. I might be apologizing only to myself, I'm not sure, but it is very troubling to me. Let's see. This puzzle is bonkers. Also, I think it's a testament to what Jesper has done to people that this is rated as a 4 difficulty. Gesture puzzles are many things, but easy is not one of them. Let's see. If this was green, surely this column is now just broken in all kinds of ways, right? If this is green, then I'd have to go black here, clue here, black here, clue here, and this would have to be a double-digit number. I unfortunately don't think I don't think we can rule out that it's a double-digit number. It hasn't taken as long as the previous one yet. That's fair. I don't disagree with that assessment. Part of a double digit. Okay. A 5 and a 10 something. Okay, and I've got to fit a 2, a 5, and a 10 here. Unfortunately, it's still very possible, I think, for me to go 2 here, 5 here, 10 here, at least as far as I'm able to tell. Row 6, column 3 also has to be green. Okay, let's try and imagine the world where this is not green. Oh, yeah, that's true. So these sum to a double-digit number. So imagining this is black, I know these two sum to a double-digit number because they're not 1. And so now when I extend that region down through this bottleneck, I now break this clue. That's super clever. Okay, so this is green. Okay, that's green. And now, assuredly, yes. And so now this column now has to look like that with these being green. Okay, I think I believe all of that. Uh, and the middle green is a 2-digit number, right? This is a 10 plus sort of number. I don't know a great way to denote that. Let's see. I think if I go into number, I think I can put a plus plus in it. And I think I can use that to sort of tell myself that this, oops, sorry, did not mean to highlight that. I think I can use this plus to remind me that this is a double-digit number. Okay. Now, I guess the fact that this is at least 10 is going to tell me that this is also part of the plus, right? Because there are literally... Oh, that's very interesting. Okay, now look at this column. This plus has to come into this column, I believe. If the plus stopped here, that is, if this was black, I would have to fit my 10-somethings all over here, which would force, because that's not allowed to be part of a 10-something. This isn't allowed to be part of a 10-something. And so all of these would be 10, and that's clearly broken. So this is part of the 10. And so now this being part of the 10 is fascinating because it actually is going to tell me that the cell above and below it is black. But it's actually even better than that because there's a 10-something clue. Oh, sorry. It's the cell above and below it is black because this is a 10-something number, and so I can't have two of them. But now that means that this digit here is a 5, and this... because if I put a second one... Oh, maybe I don't know that it's not below. What I know is that plus doesn't continue below. Yeah, I don't think I know that. I think I don't know that there's not a cell here. It's just not. I know that it's not plus, but I do know that there has to be a region here that's a 5 because that's the only way that this is going to fit. And then if I do anything here, there's a border there. That is not allowed to, the plus is not allowed to dip down. Okay. Now, if we could prove the plus... Okay, so here's an interesting observation. So I'm trying to prove that plus has to keep going, and if plus has to keep going, it's going to go here, and that's going to tell us a lot too. Plus can never go into row 10 because of the clues there. So plus over here at most takes these cells, and these cells. Oops, that's not a real cell. And it can't take that cell either. So plus is currently at most size 8. So plus does need to grow here. Number plus. Oh, right. The plus can't come into column 2 at all because there's both a single digit, which is this one, but then after the single digit, there's a 6, which, spoiler, is also a single digit. So the plus actually is not getting back into column 2. So the plus has a lot of growing to do. But somewhere below in this column, below a double-digit number, there's a single-digit number. So I can put a black here and a green here. And this is going to be a single-digit number. Continue the edge over to here for that. So based on Judith's point, the plus has to get into... I guess it could go up. I'm not sure. Okay, I think Judith's point is going to let us sort out something over here, but I can't... yes, I should edge off the plus over here, because we now know, legitimately, the plus is not going there. This is a lot of puzzle, Jovi. Well, a lot of puzzle. Uh, uh, row 5, 6, column 2, 3. Do I know that this isn't a 1, Garion? Like, why can't this just be a 1? Okay, so the 5 has to grow at least 1 to the right, because if the 5... Yeah, I made that mistake before, and Neverio caught me, thinking that this had to be black. But these could be like a double 2 even, maybe, possibly. I mean, I don't think it's likely, but I think it's technically possible. Okay, so if the 5 tries to grow entirely in this direction, we have to show that something breaks. So certainly the 5 could take both of those. Right. And then the 5 could never take... It could take this cell. It always, if it tries not to grow, is always going to take this cell. But then whichever other cell it takes, it then makes it 10. So Wise Neverio correctly nails that this has to be a 5. This is very, very well done. Well, that's super interesting. So the 5 can't be part of the 9 now, right? Oh no, it could be part of the 9 if there's 2 1s. So I think there could be 2 1s here. Row 9, column 4 is black because of the row. Right. I need a double-digit thing. And so this is at furthest, this is the second thing. And it can't be double-digit, or it would break the bank on this. So great spot, Judith. That is very astute. This is black because of the row, which makes this also black, which is very fascinating. So very well spotted. Have a piece of cake. Okay, so now I'm trying to get to a sum of 7 for this. So in particular, because I'm trying to get to a sum of 7, this is always green. Otherwise, I'm not getting to a sum of 7. Okay, and I am now seeing SPQ's comment. This needs to grow up because I know this digit is at most 7. And so this digit that's at most 7, in order to get to this double-digit total, that has to go up. Okay, that feels significant. Now, 1, 2. Yeah, I need to... Oh, I need a clue here in this column. This column, these two have to be black, right? Now, with what's forced in column 2, now these have to both be black, right? In order to possibly fit this clue. And this clue is a 6. So that can be a 6. So that 6 is going to get carried down at least this far. And the very obvious thing for it to do is to put a 6 here and a 6 here and a 1 here and then be done. Oh, it has to do almost exactly that. This has to be a 6. Because, yeah, this is forced. Okay, this has to be a 6 because I can't put 2 6s in the bottom row. This now has to be a 6 because I need to get a 6 into this row, and if I put the 6 over there, now this sum is broken. And so now that's got to be a 1. And so we can edge off the this region. And so now this is black. Not that. This is black. Okay. The 5 Fillomino has to take the remaining space because I need to get to... so these two are definitely... let me just argue that real quick. These two are the same because whatever this is, it's not a 1. But together, they need to get to a double-digit number. So this needs to be at least a 5. But on the other hand, if it was more than 5, we'd instantly break. So, in fact, this goes 5, 5, 5, finishing off the 5. Very nice. Okay. This 5... No, all I know is one of these joins. I don't know how it joins yet. Like, I think this... Oh, no. Now the plus can't go up because of this clue. This single dot tells me the plus doesn't go up here. So plus does not go up, so therefore plus goes over. Now, that annoyingly doesn't mean this cell isn't green. It just means that plus doesn't go there. But we can continue our plussing of things. But that's huge, because now look at this column. Now there's a double-digit thing. That must be this one. So this column actually is black entirely. Well, sorry. There's only one region, but it not like that. But in order to fit my single-digit clue, it's got to fit there. So, sorry, I know I'm not saying incredibly articulate words, but I'm doing my best to say words good. Okay. Right-hand part of row 10. Yeah, so the question is, how far could I make it in row 10 without breaking my single-digit allotment? So I could go 1, 2 2s, 1. Okay, so that's 6. And then I could put, say, a 2 here. So I think that's all fine. But there's no way that this cell is colored. Because if this cell's colored, I'm saying I'm summing all of these. And I don't think that works. It sounds very sus. But we can go really far, unfortunately. 1, 2 2, 1. What if we did 1, 2 2, 1, 2 2, 1? That's a nightmare. That is horrible. But I fear that we actually might be able to go all the way across the bottom. With single-digit numbers, unfortunately. Hey, Chris, how are you doing? Yes, as Garion says, that is ridiculous enough that it makes me worry. Just like this string of 7s and the 1s, when we started to do it, and it was like, oh no. There's a certain point where something is going far enough that it gets problematic. Okay, if plus bends up, it breaks this, right? Okay, so plus can't bend up, so plus has to actually keep going another. Excellent point, Judith. So we extend plus. into this unknown region. Okay. Now plus could just bend up. Yeah, there's digits in the grid. We think we have proven this. It's taken a while, but I think we're getting somewhere. Is the row 9 clue restricted? Ah, that's a good point. So row 9 now actually kind of really wants the plus. Because row 9 needs to have another double-digit sum. So... and then a single-digit sum. Yeah, so it's almost restricted. Good eye. It's very close to being restricted. Also, you just came in and you understand what on earth is going on in this puzzle, so congrats to you that you have correctly identified a point. I think it took about an hour for me to correctly identify a point in this puzzle. Should I be thinking about how I'm making 9? So the only way that I can make 9 if I make this cell green is as putting a 1 in both of these cells. Is there some reason I cannot just put a 1 in both of these cells that someone sees? I would love to know that I can't just put a 1 in both of these cells. That is the sort of thing that makes Zetas happy. The plus represents a region of undetermined size, but I know the size is at least 10. And all of these are part of the same region. So the reason for this is that I have been using green to denote is part of some Fillomino, but this one is actually important enough that it has gotten its own designation of plus to remind us that it is big. Like plus signs are big, question mark. Okay, so plus can only take one cell in this column is interesting. Oh, we never put our 2 here. Oh, okay. So this cell can't be green. Oh, wait, maybe this cell could be green. Okay, can this cell be green? That's my question now. If this cell is green, it's a 2. Now, I can't go down, so I'd have to do double 2, 2, and then this would be a 3 in this universe. Is there a problem with that? Annoyingly, I don't think so. What if this isn't a 2? If this isn't a 2, it's black. Now, what's the latest the 2 could show up? Could the 2 show up here? I don't think so, right? It'd be 2... black, 5, black. Yeah, that doesn't work at all. So one of these 2 is a 2. It's that point from earlier. Okay. Naverio has discovered a point from earlier that that is now rearing its head and making life nice. Okay. So this cell, so we're disproving this cell being black. So if that cell's black, this has to be green. It has to be a 2. This has to be black. Now, this has to be green. It has to be a 5. This has to be black. And now this has to be green. And it has to be a 10, except that it can't be a 10 because it would have to, exactly as Naverio says, it would have to go up or down. And either way, it would break the 16. Okay, so we used that much, much earlier for something. But that's big because now this is a 2. This can't be the other 2. This can't be the other 2, so that's the other 2. So that's green. I can edge in this. Oops. I can edge in this. Okay. So now this has to be green. And now this can't be green, because if it was, it would make the sum too big. So now the sum is done. So this needs to be a 3. So this needs to be a 3, because I need to get another 3 in there. This needs to be black, because I needed my total to be 2. Okay, so can this cell can't be shaded, because if it's can't be green. If this cell's green, by the column clue it's 2 digits, and by the row clue it's 1 digit. So that is not green. And now in this column, this is column 5. Now I need 3 total things. So this has to be green, is Tristan's point. Right. And Navario's point actually is actually going to let us do these two. Because if I don't color both of these, I'm going to have to either color this one and make it a 10, which is going to break this column, or color this one and make it a 10, which is going to break this column. So I have to color both, which then forces this. That's Andrew's point. Tristan's point is to look at column 6. Oh, where there's only 2 clues. So actually in column 6, all of that gets colored. Great point to Tristan. Okay, so I need to make sure these sum to a double-digit number. Wait, did I really know this can't go up? If so, how did I know this couldn't go up? Because I feel like somehow... Oh, it couldn't go up because of this rose clue. Okay, this rose clue told me it couldn't go up, because the rose clue, this still needs to be a single-digit number. Okay, and this digit, I know what it is. This digit's a 5 because of this row. So this is a 5. Doesn't that make both of these 5 as well? I guess it could be like a 6 and a 4, as horrible as that is to contemplate. But I think it could be a 6 and a 4, as far as we know. Yeah, they could belong to different pieces. This one would have to be less than 5. So this one is 1, 2, 3, 4, or 5, because it's a single-digit number. How am I getting to 7 down here? I mean, any way I'm getting to 7 has to involve a 1. But this number can't be bigger than 3. So this digit is a 1, 2, or a 3. Actually, this digit can't even be 3. No, it's not 7. Sorry, I'm reading the wrong clue. So it could be 3. Could be 3 exactly. So I was looking at the 7, but it's not the 7 that I'm supposed to be looking at. This row is very nearly interesting. Does the 5 in row 2 have to go down? That would be fascinating if true. What if the 5 tries not to go down? So the 5 could, for example, maybe finish like this? Is there a reason the 5 can't finish like this? Yeah, it is at most 3. That part stayed, but the not being able to be 3 went away. I don't immediately see why it couldn't do that. I kind of suspect we're going to learn that plus is 14. That's my prediction. I'm going to do some extra bolding for Ambrose. I'm glad I'm not the only one who appreciates the crisp aesthetic of the black on black borders. Yeah, I could like go into center mark Sudoku mode and mark this is a 1, 2, or a 3. This also can't be 4. If this were 4, it would have to get out, and that would... No, sorry. This could be 4, but it can't be higher than 4, because if this is 4, it could go 4, 4, with that being a 1. So this is 1, 2, 3, 4. Now, there's no way... I guess I should say this. There's no way this cell isn't green. I should have done that a while ago. Because if this cell weren't green... If this cell was black, I'd have to make these two just add to 7, and that's never going to happen. And in fact... Oh, I don't know that these are always part of the same region. They could... Oh, no, the 7's already done. Darn it. I am somehow obsessed with the 7 that is not there. Sorry. It could be double 2 and finish. Yep, you're completely right. I keep looking over here and seeing this. There is no 2x2 constraint. So 2x2s are encouraged. Or allowed, I suppose I should say. But yes, I was, again, for about the 14th time reading this as a 7 clue for this, but it's not. It's a 7 clue for this, and it's done, and I need to let it go. Oh, but there is a rule that says all greens are connected. Oh, well, that's good to know. Well, that's a problem. Yeah, the 6 region is certainly not connected to anything. Does it say, okay, let me look back at this. I believe you, but I am... is it really where the each region is... Each unshaded square... is an edge... I don't see where it says that it's connected. I might be blind, but I'm going to... Okay, so maybe we're okay. Maybe we have not broken a rule, because it's not actually a rule. Okay, so that panic averted. Actually, I know this cell is 1, 2, 3, or 4. Because whatever this cell is, it's going to end up going there. And it needs to be a single-digit number. Let's see, we can, like, light shade the completed clues. That's not a bad idea. Let's shade them in purple for celebration. Okay, that one's done. That one's done. That one's done. That one's done. The 9 is done. The 2 is done. The 5 is done. The 20-something is done. That single-digit one is done. This would better add to 13. I kind of don't want to check it. That's done. That's done. That's done. That's done. That's done. This is done. I missed one in row 4. Oh, yes. I also probably don't have to worry about making sure that this gets to double digit, but I'm not completely done it, so I'm going to keep it. These are done. And that does tell me that the plus is a 1-y something number at least. That 9 is done. This is as done as it's going to be. That's as done as it's going to be. I don't technically know this is a double-digit number yet. That's done. I think that is all that is known. But that was a good idea. I do plus is a double-digit number. Oh, yeah. Yeah, you're right. I do know. Yay, colors. Okay, yes. Plus is a double-digit number. Well, technically, I have to worry that it might turn into a 3-digit number, right? I'm not super concerned about that, but it might technically happen. I think I'm comfortable enough that I'm not worried about making a 3-digit number. I very much hope that I don't have to use the fact that something's not a 3-digit number. Oh, Niv has a point on the 3 region in row 3. 3's third digit has to be down. It being to the right traps the 5 clue. That combined with the 10 clues breaks the 16. Okay, so if 3 goes here, it forces this. Okay, so before we did not believe that 5 couldn't do this. So I think Naverio has figured out a reason why 5 can't do this. So this is a 5. Yeah, okay. So in the world where this is 5, here's what happens. So if the 5 does this, these can't both be 5. So they therefore have to add to 10 without being 5 each. So each of these regions that are different now have to go down. But now... Wait. This is further ahead than I can visualize. This one can't be 2. Well, it could be 2, actually. If this is 8... No, this can't be 8. This one's got to be... Okay. So this one has to be at most... In this universe, this one has to be at most 4 because of the single-digit clue, because it's going to have to go down. This one is going to therefore have to be at least 6 to pick up the slack. And so this one is going to go down 1. This one's then going to go down 1, 2. And now, I hope you could visualize all of that with me. That's too big. That's more than 16, because that is a 5 plus at least 18. Okay. So the 3 cannot go there. That is very complicated to see. There may have been a better way to see it. I probably should have drawn it in. If I'd have realized it was going to be that complicated, I would have drawn it in. Okay, but another point. The 5 now can't make it over here. So now the 5 has to go down. Because now if the 5 goes over here, well, we'll run into exactly the same problem. So this is a 5. Okay, I know absolutely nothing about this row, absolutely nothing about this column. I am doing the one from Jesper. Have you done this puzzle, Playmaker? And if you did you find this puzzle to be incredibly, incredibly difficult? I'm absolutely loving this puzzle, but this has been this has definitely required bending my brain in ways that I did not anticipate. Uh, let's see. Got the single digit thing here, which is what's telling me that this is at most a 4. Okay, so this digit is at most a 5. Uh, because either it is a 5, in which case it could go over here and then there's no problem. If it's not a 5, then these two digits are different and this digit needs to go up or down, in which case it needs to be at most 4. So I am comfortable... Oops. I am comfortable pencil marking 1, 2, 3, 4, 5 into that, which means we can pencil mark 5, 6, 7, 8, 9 into this cell. And this can't actually be 9, because if this was 9, this would be 1, and the 9 would go up or down, which would break the 16. So this is not a 9. So this is not a 1. Okay, it's not 8 either. Because if it's 8, this is a 2. We'd go 2, 2, 8, 8, 8. The 8 would have to... yeah, and 2 and 8 is too big. Right, okay. So yeah, if this was an 8, this would have to be a 2. The 2 would go up. The 8 would have to get out of this column. And now it's going to have to pass by the 2, and it's going to be way too big because of this single-digit clue. I keep trying to read this as a 14 because I'm sometimes not a very observant zeta, but this is supposed to be one cell, so this is not an 8. So this is not a 2. And so probably the same thing actually happens with 7. If I try and do 7, I can't go down more than 1 with a 7, and so then the 7 is going to go next to the 3, and because they add to 10, that's not going to work. Okay, so 7 does not work. 3 doesn't work. Okay. 6 is going to break in the same way, right? Because I still can't go 3 down with a 6. So 6 is also going to touch the 4, and so this just is 5 and 5, right? I think, yes, it turns out that if we'd have actually thought about this, these two add to 10, so they can never touch in this column. And so we'd need to be able to get at least this far down in order to get away from this one, but that's just not going to work. So it is 5, 5. Which would maybe have been a much easier way to prove that this 5 didn't get up here. But what are you going to do? Okay, so this 5 can't go up or down because of this one cell clue. So the 5 has to escape up or down in this direction. I don't think I necessarily know which. Well, I guess no. I know it has to go down. Even if it goes up, it can only go 1 up. So it always takes this cell. And can't take this cell. So this is a 5. Oh, and if it took this cell, I'd be dead. Because if it took this cell, I don't have any cells I can take. So actually, the 5 region is forced. So it has to take this cell, but once it takes this cell, it can't take any more. And so then the only cell it can take is this one. So Andrew called it correctly when he said it's a backwards C. 5 and 5. Okay, these two 5s need to have a black bit between them. One of these is a 1. I don't know which. Well, I can't put a 333 polyomino here. But I certainly don't think I know that this isn't shaded. Now all of row 4 is green. Sorry, row 4. Oh, right, because as soon as the green touches this, it forces these to be green. Because I needed to have only 2 contiguous streaks, so that's a plus. Let's see. Top row has to be 3331. Oh, we need to get... Okay, so... okay. Got it. Okay. So now the key is to look at this clue in concert with what we know about the stuff up here. So this cell absolutely cannot be bigger than 4. This cell absolutely cannot be bigger than 1. So this is either 0 or 1. This is 0 or 1, 2, 3, or 4. 0 meaning black. Now, all of these also are at most 4. Because actually the space... Actually, sorry, no, this one could be a 5. Yeah, this actually... Yeah, I was going to sort of elaborate that, but then I thought I was going to do this more elegantly, but I'm just going to do it painfully. This can't be a 4, because if it was a 4, it would need to fill these spaces, and then it can't. If it were a 3, it would fit in exactly, and that would be fine. I think we could do 2, 2, 5, 1, I think would be fine. Or I think 1, 3, 3, 3, I think would be fine. I think both of those are acceptable. So, but either or both of these could be 5, I think. Yep, I think 5, 5, nothing, nothing, I think also is fine. 5, 5, 1, I think is fine. I think there are many combinations of stuff up here that work. This, though, this can't be 0. This has to be green. No, sorry, that's not even true. This could be 0 as long as that's 0 as well. Okay. I'm kind of sus about this being the 1, because if this is the 1, it's part of an 8 clue. And so could be something like 1, 3, 3. No, that doesn't work. Well, it would have to be... Okay, so if this is the 1... This digit absolutely cannot be a 7. Because then the 7 can't go left and it can't go down because of the clues here. So this would be an 8 sum. If this is 8, this is an 8 sum in 3 cells. With this being the 1. And now this digit is at most 2. So it would have to be 2, because if it was... Because these 2 digits can't be the same, because they won't add to 8 if they're the same. So the only universe where this possibly works, with this being a 1, is if this is a 1, this is a 2, and this is a 5. And so then this 2 goes down. And I unfortunately don't see why... this it can't be 1331. That's too many digits, Christoph, because we still need to fit a black in here. So it would have to be exactly this. But I don't see anything wrong with this. It's certainly bumpy because there's lots of fives floating around, uh, but I don't see it as broken, as best I can tell. Uh, I mean, it could be a new five, right? Like, couldn't this five also be a C, this be a double two, and then this be a new group of fives? I mean, the 14 clue could just be a single plus, right? I assume that the 14 is going to be plus. I could be wrong. It's totally assumption on my case, but I think that's what's going to happen. Um, so I don't see a way to rule out this combination. But if this is a 1, this is exactly what happens. Uh, I mean, otherwise, how on earth else is this working? Like, this 8 we've got to do somehow. It can't start here otherwise. Uh, oh, I guess it could have a 3 here and then pick up a 5 here and then a black there. Uh, uh, can't fit a plus into column 9. Why can't plus be 14? The dot clue in row 10. Yeah, this plus definitely can't make it to row 10. Uh, I think a lot of people have proven that, or think they've proven that plus can't be 14. Uh, uh, but I'm not sure that I have seen this argument yet. Uh, is the idea to figure out where plus could possibly go? Oh, well, here's an easy point. Plus can't go up here. I don't know how long that's been hanging there, but it's true. Plus can't possibly take this cell because of this row's clue. Oh, I think there's been more greening since then. I think this was Tristan's glorious greening, and we did not appreciate that Tristan's glorious greening means that 14 or that the plus clue can't go up here. The plus clue almost certainly goes down here, but who knows? Uh, the 8 is super awkward. Uh, One is under the backward C. then plus can't be in column 9. It doesn't fit. Okay, so we'll go... So if this is a 1, then we need to go black, and then we could do, say, 2 14s, and then a black, and then a single digit. It's column 10. Column 9. So if this... So you're saying fill in all the pencil marks I had before, where this is a 1, so this is a 2, so this is a 5, so that's a 2. So now we go... Okay, so now we look at... so this now has to be black. And we've got 2 clues done. So then we've got another single-digit clue. And this would have to be black. And then this would have to be a 14. But it can't be a 14 because of the row 10 clue. Okay. I agree. If this is a 1, through the perverse structure of this 8, this would have to be a 14, but it can't be. So that breaks. Well, it breaks the ability to put a plus clue into column 9. It doesn't mean there's not a 1 there. It just means we'd have to... Plus probably would not end up being... 14 in that instance. Oh, right. Because the 14 clue here is saying I'm supposed to get 14 down here, and that doesn't work. Okay. Got it. Okay. Right. Okay. So the point is, just don't even think about the plus at all. Think about the 14 clue. And so the 14 clue now would need to go there, and it can't. Okay. So this doesn't work. So that's not the 1. So that's black. This is the 1. Sorry, this is a 1. So this isn't 1 or 0. And so we have to extend at least over to here. And we can't even possibly green these 3 cells without also greening this one. So all of this becomes green, which we can continue thinking about in a moment. Okay, so now my 8 needs to start here. Don't forget to edge the 1. Yes, that's an important puzzle step. So this 2 or 3, whatever it is, it definitely goes here. Yeah, so this cell is... So in all universes, this is either 2, 2, in which case this needs to be a 5, or this is 3, 3, 3. So if you want your candidates marked, this is always 3 or 5. This is always 2 or 3. Right. Okay, so the 5 could take this cell. It could take that cell. But that's still only 4. And the 5 can't take this cell because it's touching a 5. So actually the 5 always takes that cell. That's a good spot, Tristan. Okay, so this is definitely an edge between these things. So some number goes here, but that number could be a 1. Who knows? Okay, I still need to fit an 8 in here somehow. Okay, so maybe the point is, okay, if this cell was black, it would force this to be an 8, and that's immediately broken. So this cell isn't black, it's green. Now, if this cell is green, then that breaks, because if this cell is green, now I don't have room for an 8, so this cell is black. Yeah, someone was saying L-shaped 4. L-shaped 4 definitely looks good as far as this goes. Let's see, Kurbon says row 10, column 10 is black. I feel like we did... Oh, right. That being black now forces the 5 pentomino, because now the 5 pentomino needs both of those. Okay. Thank you. Those are both 5. That is green. We can edge it in. These are both 2. We can get rid of the line. Okay. So before we wrote out a way, let's see. Okay, so it was 1, double 2, 1, double 2, 1, I think was our way of doing it before, which was sums to 5, 6, 8, 9. So that combination works, unless there's a reason why that doesn't work. But this combination working makes me suspect that there's not going to be an easy way to disprove this. Let's see. Can I disprove that this is an 8? Because if this isn't an 8, then that's green too, which would be nice. But I don't see a lot of reason why this can't be 8. Let's see. Are there other clues? In row 7, column 9, let's see, 4, 5, 6, 7, column 9. Let's see. Playmaker asks if this can be black. Okay, so if this is black, Playmaker points out, that implies by the row that this cell is a double-digit number. But then by the column, that's clearly broken, because the double-digit number could not go up or down. So in fact, wait, why couldn't this be the double-digit number, Playmaker? Why couldn't I go black double-digit number here that's part of the plus and also black in that cell? Happy Saturday, Finland. Hope you're doing well. We are having a fun little adventure with this puzzle. Uh, yeah, if this were an 8 Fillomino and the plus we know is it has to have at least 5 more cells. So this plus needs to take at least 5 more cells. And the 8 would have to take, of course, 8 cells of some sort, which is a lot, but does not immediately. I don't see a thing I can count that immediately precludes that. Uh, let's see. Should we highlight every cell that plus can potentially take? Plus could potentially take. It can't go into row 9, but it could potentially take both of those. It could take all of these. It could take that cell. If plus were exactly 14, I think it could take that cell. 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't think. Oh, that's right. Plus can, if plus can take a cell in each of these columns. Right. That's easy. Okay. Uh, okay. Yeah. So it can get up to 13. I think is the answer if I'm counting correctly. Uh, Although I think it's going to be hard for it to take both of these, but I think yeah, it's at most 13. It's not 14, but it could be part of the 14 clue. Uh, yeah, this being difficulty 4 is quite a thing. Uh, by my it is possible that I am not very good at this. That is one possible conclusion that one could reach. Uh, if this was green, is that a problem? I don't think so. Uh, so let's see. How many spaces do we have left? The annoying thing about the 8 is that the 8 could come over and take like all of these cells, and that's not actually taking that much. It could take that cell too. Uh, oh, it can't take that cell. That would make this. Actually, technically, it could. Uh, though that's not enough cells, so it would have to take something awkward. Uh, yeah, I think the I think these are the cells that the 8 can take without pain, but I think then the 8 can take this cell and finish. And I would be willing to believe that we've now made it impossible to fit plus in, because we've used a lot of the cells that plus could take. Uh, so, so I guess maybe correct thing is to sort of count cells that plus has to take. So plus can take nothing out of row 10. It can take up to 2 cells out of these 2 columns. So currently we're at 2 for what plus could take. And so it has to take at least 3 cells beyond this. But unfortunately, that's pretty easy for it to stay down here and then put the 8 up there, which I suspect is going to create a problem, but who knows? I mean, is there any way that plus finishes without taking a cell in column 9? I don't think it's possible for plus to finish without taking a cell in column 9. I think it's going to have to. The 14 is going to have to be plus whatever ridiculously low number is down here when this extends over here to everyone's surprise. What if plus took 0 cells here? Maybe we just need to prove that plus needs to take a cell in column 9, because I don't think it's possible for plus not to. If plus can take none of these cells, I guess it could take these 2, 3, 4. Yeah, I guess it could just get to 5. Yeah, I guess it can just get there and then sneak back across and go 6, 7, and then take all these. That is unfortunate, but seems to be about where we are. Okay, let's try this again. Let's try this seriously. We're going to not take any cells in any of these. So we could take these 3 down here, and then we could go up. We can't ever take this cell, so we'd have to go up. But that's enough cells, right? Can't take anything in 5. What 5? In row 5. It's not taking anything in row 5. That makes 10. This would have to be black. This could do whatever. So yeah, maybe it's possible that it doesn't take anything in column 9 and 10. Maybe it's just possible. 4, 4, 4, 4. The double 4 breaks the 9 clue. What 9 clue? Oh, it breaks... right, it breaks this clue. Right, okay. So this cell, we are learning that... okay, this is a good point. This cell cannot be part of plus. Because if this cell is part of plus, then making the 8 clue work becomes impossible, because this digit has to be... well, first of all, you definitely can't put an 8 here, because the 8 gets blocked in. And this can't be part of a plus clue because this digit has to be at most 4. And so this digit has to be at least 5. This digit has to be at least 4, but it's not going to work. So plus can't take this cell. And if plus can't take that cell, so that's the point. Plus can't take this cell. If plus can't take that cell, it certainly can't take this cell. It can't take anything before the end of this. I think that proves plus has to take something in column 9, because now plus at its absolute maximum, plus is 9 cells. So plus is part of the 14 clue, I think is what we found. So I think plus takes 1 in column 9, and I don't think it's going to need to take something in column 10. I don't think. It might just be able to, but I don't think it needs to. Why do I care if I can take a digit in column 10? Is the idea that if I can pin this down so precisely that I'll know exactly... Yeah, I guess I am actually closer than I think. ELLSF is right. I think I'm closer than I thought I was to actually knowing it has to take all of these cells. Because it can take 1 in column 9. And it certainly can take at most 1 in column 9. But what if it took, say, here in column 9? Could it go this high in column 9? Let's see, it can go black, green, black. It could go this high in column 9. And so it could go this high over here. And it could go black, and then we could put this here. And then we could do the double 2 thing with a 10 to make the 14, and then have to do the ridiculous... 1, 2, 3, 4, 5, 6, 7. Plus can't go up in column 7 because it would make this double digit. Knitting by Franco. I do need to fit a single digit at the end of row 10. But I think this is going to be all green. I think. But I could be wrong. Row 9. I see. Okay, this single digit is interesting. Okay. Okay, so that that single digit is very interesting. So somewhere in the end of row 9. Okay, so plus takes at most these 4 cells plus 1 cell from one cell from column 9 and 1 cell from column 10, I think, right? We showed plus can't actually take this cell. So plus needs to take a cell from column... plus needs to take a cell from column 9, regardless. The highest that cell can be is if it goes black, green, black, green. This is the highest that cell could be. So it's one of these two is plus. I'm going to mark that with a line. One of these two has to be plus. I'm going to mark can be part of the region per Kurobon's earlier suggestion. I'm going to mark these like this. But if it's the bottom one, we break that. Okay. So that's the key piece that we were missing, but that chat spotted. This single digit here means this can't be a double digit. So that actually Uh, that actually means this cell is definitely plus. Okay, so this cell, this is green, and it's plus, which means this cell is definitely green and it's plus. Because I can only take one green cell in this column. Okay, and now I might or might not be able to conceivably take a plus here, but I need to take at least... are we sure the column 9 plus can't go into row 7? Yes, because I need to have another green clue. So I could go black, green, black is the fastest I could go. And so this cell's still black, even in the fastest universe. And in fact, actually, that's forced. Because we still need to fit our last single-digit clue here. So that structure is now forced. This is green for sure, we now know. It's not plus, to be clear. It just is green. Okay. Okay, so I think we're now getting to the point where there's no universe... Oh, I was about to say I think we're getting to a point where there's no universe where there's an 8, but in fact, actually, it's the opposite. We have now found a spot where there actually is an 8 there. Okay, so this now is an 8, which means it certainly in all universes has to get out and put an 8 there. Okay. Good point. Okay, so ELOSF has a good point. This row needs to have a space between its single digit, which is this number, and its double digit number. Which means this cell is not a plus. Okay, ELSF has, I believe, proven this can't be a plus. Because if this is plus, then now row 9 is broken. So I think this is actually, ELSF has proven not plus. Which now means that because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at most, this now has to be this. So you had excellent insight that this was almost forced, ELSF. I was very skeptical, but now actually, but you were completely right. That's plus and plus is done, because plus can't take any other cells in any universe. Right, this is plus's shape. And so plus, actually, we can go back, we can delete the numbers. Sorry, I guess I have to fill these in one at a time. Okay, so plus is 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. Okay. This cell's definitely black because we need to get a single digit before we get to double digits in this row. This cell now has to be black because I only get 3 clues and I have them. The 8 now always takes this cell. And for that matter, this cell, because it's like 1, 2, 3, 4, 5, 6, 7. Okay, so this is green. Please no one point out the puzzle's broken. We're just going to pretend that it worked. Let's see. So this column, yes, this column only gets, wait. Right. This can't be the 10-something clue. So this is black. So now I still need another clue after this one. So this is green. Now that green's the entirety of this row. For that to work. This row needs this to be black. So I think we're done our coloring. Okay, so now let's look at the 8 business. So let's see. The 8 can take at most... Okay, there's only 8 cells the 8 can take, so the 8 needs to take them all. So that one, that one, that one, and that one, and my 8 region is done. Okay, and so that makes this a 1. Not that we were ever super concerned about what exactly was happening there. Okay, so if this was a 1, this would need to be a 3, and that would hella break row 9. So this does need to be 2, 2. Despite our repeated attempts to prove that this was not possible. This is a 1. Okay, so in this puzzle, I think every time you tried to prove something that was every time you tried to prove something was not possible, I think, and then you ended up running down this path that was longer than you thought it was going to be, then it turned out to be correct. Okay, so now this certainly has to be a 1. There's no universe in which it's a 3. So we can Sudoku in a 1. Put in this edge. And so now this certainly has to be a 2, because again, if it was a 3, we would way overflow our thing. So that puts in a 2 and a 2. And now this is a 1 by force. And we have finished the puzzle. Wow, that was a ton of fun. What an adventure, and holy crap, is this not getting a 4-star rating for me for difficulty. But what an adventure. I don't think I've ever been so in doubt in doing a puzzle on stream that the puzzle was actually going to get finished. But definitely, even I think 45 minutes into this puzzle, I think that was, I was... thinking, like, is there any way that this is going to finish? I don't know. I have no idea what is going on. But the ending is so pathological. Like, I mean, every step, like even this step, when we were doing it at the beginning and we were trying to prove that this couldn't be black because it would force exactly this combination, and then it's like, oh, 1 and 1, and it would work. And then it was sort of like, okay, maybe it does have to be that way. But yeah, at every step, and then this, like, it was so clear that we were supposed to prove that this had to be black, but then it wasn't. Thank you, everyone in chat, for keeping me honest through this, because I'm certain I convinced myself I had proven things that were wrong. And of course, this is a puzzle where if you prove something that's wrong, it's not going to go well. Yeah, definitely, yeah, was a nice, easy 4-star puzzle. We can try a real 5-star next time. Ooh, boy. Okay. I am going to do Elosif's suggestion to do the example puzzle. So let's do the example puzzle. And see if, now that we know things, we can do the example puzzle more easily. Let's see. Okay, so this is a 7 by 7. So I only get 1 cell in this row that is Yeah, it's going to turn out this puzzle is even worse than the other one. This only gets one free cell between going thing and thing. Let's see. I don't have any 2s meeting. So this is a 2 and then a double-digit number. Yeah, maybe the example puzzle was 4 stars. That would make a lot of sense. If I'm perfectly honest, I don't see anyone to start in this one either. Let's see. Okay. This cell cannot be green. Because if this cell is green, it's a 2, but then it's a 2 going horizontally, and that breaks the 3. Okay, so I have a start. This cell, not black. Or sorry, this cell not green, and this cell not green. So that's a little bit of a start. Let's see. So can this be the 3? Okay, so that is actually a hint to how we eventually broke into the previous puzzle. Now, I don't immediately see any reason why this has to be green. If this was green, it would have to be a 3, which would be great. Yeah, column 2 now. We've got some 2s. Oh, actually, yeah, column 2 is now completely forced. I miscounted when I first did this. So column 2 now has to do that with these being green, these being black, and this being green. And the green is our plus for this puzzle. So we can put a little plus, and we can have a plus region again. So now plus definitely goes here, because plus can't possibly get to 10 cells in column 1 alone. So plus at least comes to here. Okay. Yeah, good old plus is back. Yeah, let's see. This has to eventually end. Let's see. If plus turns up here, then that means this was a single-digit number. But that seems possible. Oh, okay. So I think Andrew Sarkis has a great point, which is that these can't both be 3. If they were both 3, then this would need to be a black cell to separate them, and that doesn't even actually work. So one of these, at least, is not a 3. I don't know quite what to do with that yet, but it's true. So these 2s each go horizontally one direction or the other. Yeah, so one of these is black. I don't know which one is black, but one of them is black. I mean, it would be really natural for plus to back that ass up, question mark, to here and satisfy that 2, which would then make the 3 go up here. Can we actually prove that it's not possible for this single digit to be anything other than the 3? I worry that it could be like, this is black, the 2 comes here, or something like that. That possibility chills me a bit. See, this column needs 2 4s and a single digit. Okay. Plus certainly can never get down to this row. Okay, let's... Okay, Jay says if this is the 3, we run into problems with the plus. So if this is the 3, then we go down like that. This becomes black. Wow, that's cool. Okay, that's really cool. Okay, yes, Jay is completely right. If this cell is 3, then that fills in the 3. This becomes black because the single digit needs to be finished. But now I need to get to a double digit number in 3 cells with a 2 blocking the way. So that's not a 3. That's black. And so that means that, in fact, this is a 3. It's just going to, oops, wrong kind of 3. These are 3s and are green. And so we then, we don't get a black. We actually get a green here. I can edge this in. Oh, and then I can extend to the 2. Oops, sorry, I want the thicker kind. Okay, so the 2 needs to continue to there. Sudoku 2. Do in the edging. Okay. Now, we still need 2 separate things here. So this is black, and this is green. So row 6 now forced with the ... clues. Ah, right, okay. So yes, because now that sums to 9, so I can't make it any bigger, thank you. And so these are green and green. Good spot, ELSF. And so that's black. I think you were right, actually. I think you then doubted yourself, but I think you were right. Yes, sums to 7. We should definitely assume that everything in the puzzle sums to 7. This is either 1 or plus. It's okay. I miscounted 2, so these things happen. I mean, this is probably a 2, but it could be a 1. Row 7, column 1. Oh no, oh no. Jay is right, unfortunately. We didn't know that one of these had to be a 3. We just knew that they couldn't both be 3. So I don't think it was actually correct to put a 3 here. Which is very unfortunate because it undoes a lot of steps. Okay. Can this cell... I guess it can, unfortunately, be part of something. Okay, there's a 3 and a 7 in this row. Okay, the 3 could go here, space. I can't have a 7 here. And I can't actually have a 7 here either. So if there is an actual physical 7, it has to go here. For the row, which seems unlikely, but maybe possible. Row 2, column 6. and row 6, column 6 have to be green. If they're black, then this would be a 4. Okay, so if this were black, let's just imagine the world where this is black. I can't do... Well, this would force me to... Right, okay. So if this is black, then that naturally forces that either this is a 4, which it can't be, because it needs to extend left. The 4 would extend left or right and break both the 3 and the 7 clue. Or if this isn't the 4, now I have to fit in the remaining stuff in this column, but now this is a 4 and we have the same problem. Okay, that is very clever. Very good spot to Garion. So this is, sorry, so that's green and that's green. Now, can this be black? Or sorry, can this be green? No, right? If this is green, we can't possibly finish this row, right? If this is green, we now have at most, we now have at most 2 dots. So this is black. In fact, actually, this is also forced to be black in order for us to possibly accommodate my 3 dots in this row. So that seems promising, which now forces this 2 over here, which if this is right, means that J was completely correct, that there was no reason there had to be a 3 there. I mean, J was obviously completely correct that there was no reason there had to be a 3 there, but also saved our butts by noticing that there did not have to be a 3 there. So yeah, so this can't be a 3 anymore. Okay, so this column needs a single-digit thing. Yeah, this is definitely green. And there's no way that this is a green that single-handedly satisfies this, so that's green, which means that's black, which means that's green. Now we're actually in this point where by classic Fillomino logic, this is actually forced to be plus extending back here, because I can't make this a 2, and I can't make it a 1 either, because it would make... Actually, sorry. This could be a 1, but this has to be a plus. So... Sorry. This is a plus now, and this is a 1 or plus. And this now is a 1 or a 2. I do need to eventually fit a double-digit sum in here. Now plus can't go up to here, because if plus came up to here, it would break this clue. So we can edge in plus on that side, at least. Weird asymmetry sort of building out of this. Must go down through the green cell in column 4. It can't take the green cell in column 4. But yeah, let's do our what are places that can't possibly accommodate a plus. So I can't possibly get anywhere like that in terms of plus. And this is only if plus never makes it up, then if plus never makes it into row 3, then plus is capped at 9 cells. So plus has to make it into row 3. And the only place that plus can make it into row 3 is here. So this is green, and this is green, and this is black. And this is plus. Does that sound like the correct deduction out of this? I would more say, Megalam, that it was such a disaster that we're doing the thing. Okay. Now, because I can't get any pluses over here, I kind of feel like this is going to have to do that shape. Like, I can't imagine what else it's possibly going to do. If this becomes green, I have to sort of like squeeze out of this, but that seems maybe possible. If 2 went like this now, that's a 1, and that's a 1, but that's actually... I don't see an immediate problem with that. Did you do this one, Mega Lamb? Okay. I do know I should put in... I know plus... Oh, and I know the plus had to get here from below. There's no way that's not a plus. And so then the question is, if I take all of these, then that would be exactly 10. Thank you, Jason Muck. We have a new patron. Thank you very much. It would be really natural for plus to continue up here, of course. I feel like I'm supposed to figure out what's going on with the 7, but I feel like I don't know what's going on with the 7. Row 4, column 7. But couldn't I put a black cell here and then 2 green cells here? I agree there's not a second 10-cell plus region, but I'm not sure. What do I gain by knowing that this isn't? Or what is the claim exactly? Oh, the claim is that if this is plus, then it breaks. Okay, got it. Because if this was green, then now in order to make this row work, got it. Okay, yeah. So this can't be green. Because if it was, then this would be black, and this would be another 10-cell region, which is just not going to happen. So we're just going to blacken that, and so that's going to force plus to wind around here. I feel for people who are experts in Japanese sum Fillomino, maybe the example puzzle is a 4-star puzzle. So these are pluses. This can't be plus, because plus can't dip into this row at all. Plus can't dip into this column at all. So now plus needs to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, plus needs to go up at least one more. So this has become plus. Plus is now at 10 cells if it takes this cell. Okay, plus certainly can't make it into row 1. Or column, whatever that one is, column 6. Plus could maybe bend backwards. I think that might be okay. What if this isn't the 3? Sorry, what if this is black? Then I have to start a 3 here, which could maybe look like a double 2 and a 1 and a black, but then that would put a 7 here. Oh, but I can have a 7 here, at least naively, because I could go up a whole bunch, like up to there. That's 1, 2, 3, 4, 5. Oh, no, I can't. Okay, this is still not going to work. Because I can only hide 1 7 away in this column. Okay, I think if this is black, it breaks. Okay, if this is black, we've got to get our 3, and there's no way that I can get a 3 that doesn't involve taking both of these cells. In fact, it would have to be verbatim. Wait. Okay. I think I can argue this, and I think it's huge. It would have to be verbatim a double 2 and a 1. So then this would be black. And now this cell has to be a 7, but I can only hide 6 7s in the grid before I run out of places to hide 7s. So what we're saying is that's not gray, so it's green. Well, now literally the only thing this can be is a 1. Because if it's a 2, we're already too big for the 3. So then, by similar logic, that's a 2 and that's a 2. This does echo the bigger puzzle. I am impressed by the tutorial, although I feel like I might not have gotten the tutorial without having done the original puzzle first. Okay, and so now both of these are green, because I certainly can't make this a 7. Now, is there any way this isn't double 2? Maybe I'm not prepared to say yet. This is certainly at most... Oh, this can't even be a 4. This could be a 3. Okay, let's write in the candidates. This is a 1, 2, or 3. Right. The point is, okay, so I think the point is, and this is also a point from the bigger puzzle, even though naively there's definitely a bar here. Because there's no digit I can add to itself to get 7, is the point. And so one of these is extending up. And so this is either a 1. If this is a 1, then this is a 6 extending up. Unfortunately, this being a 6 and extending up, I think there's just room for. I think I could hide it there in the middle. And make this a 1. Oh, no, that doesn't work, because then this is a 1 and this is a 3. That does not work. Yeah, okay. So this cannot possibly... So this cell, we're saying, is not bigger than 2. It's either a 1 or a 2. So this is a 5 or a 6. If this is a 1... then this has to be a 6. But then this also has to be a 3. And so the 6 goes up past the 3, but then that pushes the 3 up, which pushes the 6 up, which pushes the 3 up. And you'll see there's lots of problems, because now, for example, this is summing to like 14 or something, and it's only supposed to sum to 4. So actually, it's the other way. This is a 5, and this is a 2. Okay, so if that's a 2, this is a 2. The 5 needs to get up at least to here because the 4 is done, so that's black. And so these are all 5. This row can't have another black, so that's green. See ya, Directionary. It was cool seeing you on Rank's stream today. This can't be green or it would break column 6, because then there would only be 2 contiguous green stretches, so that's black. So now this is black by this row clue. So now this is the 5. And so we can finish edging in the 5 for Ambrose, who is, I'm not sure, still here, but we're going to do it anyway. Okay, and so now... okay, that's a 5. Okay, now this needs to make a sum to 4. And now there are maybe more options on how exactly my sum to 4 is going to work. Let's see. Okay, this is a single digit. By the way, welcome, Fred. I'm not sure I've seen you around before, but welcome. You've been very helpful in discussing all of these crazy puzzles that we've done today. All 2 of them, or 3 if you count the example puzzle that we decided to do afterwards. 3, 7 in row 1. Yeah, okay, that's a good question. Okay. So could this cell be black? If this cell is black, then... oh, okay. This cell can be black, because then this can be a 3 bending backwards like that. And then this would be black, and then these would need to sum to 7 in some fashion. How on earth... But that doesn't work, because how on earth am I making a sum to 7? Okay, so here's another point. This digit can't be 4. Because if it were 4, it would need to take exactly these cells, and that doesn't add to 4. So this is 1, 2, or 3. If it's 1, this is a 3. Which seems plausible. If it's 2, this is a 2. Which seems less plausible. But possible. Row 2 breaks. Oh, if this is a 2... You're saying if this is a 2, row 2 breaks? This is a 2 going up like that. Then I would need to hide a 1 over here somewhere, but who cares where? I feel like row 1 breaks if this is a 2, but I think one of you is seeing something much simpler as to why this is not... Oh, row 1, column 6 is green. That is a fantastic point from J40. So now, this cell can't be black. Okay, excellent. This cell can't be black now, because it would be the sum of 2 digits that are each at most 4, because, in fact, each at most 3, which is not enough, because they would need to fit in here. So that can't be black, so that's green. Uh, oh, okay. And now the 3 is forced because now I have to do this in order to fit the 3 in. And so now the 3 needs to bend down. Well, the 3 needs to go at least this far down. So Sudoku 3, 3. Other kind of Sudoku 3, 3. I can draw in some edges. That does force back the 1. Sorry. It forces back the 2. Okay, try 3. It forces back the 2. Like that. And if the 3 went right, it would cause all kinds of problems with this row. So the 3 goes down. In fact, this cell has to be black because otherwise we have all kinds of problems again with this row. If this is black, then now I've made a bajillion sum in a single cell spot. Okay, so now we're making 7, which I think is going to have to be a 1, a double 3. We actually can resolve plus now, actually. Plus is now 10 in size. In order to work. Okay. It's seeming like... well, let's see. Okay, let's at least do 2. If this is 2, this is 2, and now this is 1, and now this is a 4 in order to make the 7 work. That definitely doesn't work. Center 2. If this is a 3, then this is a 1, and so the 3 bends around there, like that. That's a 1, and that's broken. So that's not the 3. So this has to be a 1. Our camel is coming into focus very well. I agree. So this is a 3. Now the 3 always takes this cell, but that now tells us that's a 1. So that's a 3. And so we get a celebratory thing telling us we did it right. But we've got to do in some edging first. So there's the 1. There's the 3. Okay, in under an hour, we did the example puzzle. Which I will admit was a very good way of sort of like introducing a lot of the little pieces of logic, although it was still quite challenging, even having understood the logic of the other one. And yes, on this one, all the greens are connected. Because it was looking at this picture, I think, that... oh, sorry, not that picture. Oh, I closed the picture. But was looking at the picture of the solved grid here that made someone think, oh, the green's supposed to be connected. Example puzzle does a great job of scaring away people. Example puzzle needs an example puzzle. I do sort of feel like the example puzzle could really use an example puzzle. I feel like if I were doing this, and this is not at all saying that Jesper should do this, just saying if I were doing this, I think my example puzzle, I would have put numbers in for all the dots and let it be, let the example puzzle actually be kind of easy, but give you some of the key insights. Yeah, how much would this have made the other one easier? I mean, I think at the beginning of the other one, we kind of bifurcated. Like, I feel like at the beginning of the other one, we came up with a not entirely satisfying logical explanation for why this cell couldn't be a 2. And so I think maybe having done this example puzzle, we might have come up with a more satisfying explanation as to why this wasn't a 2. Also, there are something like 40 or 60 of us, and so together we were able to piece together all of the logic for this. Whereas if you were doing this on your own, I can only imagine that it would be easier to get through the example puzzle. Although, honestly, if I was doing this on my own, I'm not sure I would have made it through the example puzzle. Much less much less the other one. But I really the sort of bifurcating thing we did at the beginning of this, I feel like almost certainly was not the intended path, because everything else in this was so smooth. I mean, it was very difficult, but everything else in this was incredibly logical and straightforward. I think there was some path that maybe would have been more clear having done the example puzzle first. But there were so many different there are so many different pieces, and I do think the example puzzle was very well constructed to sort of give someone a little sneak peek of what they were in for if they decided to do the real puzzle. Now I'm terrified of what's going to happen when Jesper posts a 5-star version of this puzzle. I think bifurcation is a sort of like, it's in your heart thing more than anything else. But I think in our argument that this cell could not be 2, I think we ended up writing in a bunch of digits and also using like every clue in the grid to eventually say like the eventual path was that this, if this was a 2, the eventual path was that this 10 put a 10 here and broke this 16 clue. And so it was like, it bounced all over the place, and I think there was probably a slightly more concise way to do it. Yeah, I think saying it's a fuzzy term used to imply personal preference for look-ahead depth is the perfect encapsulation of what it is. But I really like the definition of, if you can visualize it, then it's not bifurcation. But what makes it a little weird for me to use that definition is then it becomes you're not bifurcating if you're better at visualizing, which is a little strange. So it's like, so then the question, can this puzzle be solved without bifurcation? Then the answer is, well, if you're smart enough, which is not a super satisfying answer. But by the way, after this stream is over, which is going to be very shortly, we're going to redirect you to Ranksk, who, if you recall earlier, directed you here. And Ranksk is going to play some fun word games and maybe do Redactyl. I'm very fond of Redactyl lately. So we'll be sending you back over to Ranksk, who is streaming approximately 12 hours a day, is my understanding. So you can go see some Redactyl and various other Erdls, as the Shut Up and Sit Down podcast has started calling them. So you can enjoy all your Erdls. And then we'll be back here on the zetamath channel on Wednesday with more puzzles. And maybe on Wednesday, maybe not, we might do more than 2 puzzles. We'll see. Or maybe I'll start with the Jesper Yin Yang, which I've heard is nigh impossible, and then we'll do half a puzzle. So I'll send you over to Ranks now. Thank you all. Thank you to all the patrons. Thank you especially Franco and David Ratner, who have given an amazing amount of support. But thank you to everyone who supports the stream. Thank you to everyone who comes to the stream. It's been a lot of fun hanging out with you. If you want to become a patron or member of the stream, you can either go to patreon.com/zetamath, or you can click the join button down below. You can get those fancy penguin emotes and a windmill like Eleventicles is showing off right now. You can vote on what puzzles we do. So the first puzzle we did today was voted on. I always do the most popular one. So feel free to do that. And with that, I'm going to send you over to ranks. Thank you so much for showing up today. I had a lot of fun. I really loved this Jesper puzzle. I hope it was clear from me doing it how much I enjoyed this, even if it was one of the harder puzzles for me that I have done. But I really, really enjoyed this one. So thank you, everyone, and I will see you all soon, I hope. Bye-bye for now.